Hola. Hello everyone, good morning and welcome in GUADEC Day 2 and the first track. We are going to start the day today with our next presenter, Federico, who everyone knows, needless to present him. And he's going to talk about modernizing evolution data server.
Thank you. Can you hear me all right in the back? Everyone? Okay, perfect. Well, before starting with all the technical stuff, I want to make use of a really old legend from Mexico. In the beginning of time, when humankind was new to the world, everything was cold because humankind did not know fire, did not have a way to warm themselves. So people had to eat raw seeds. They had no way to cook them. And the elders in the village sat down to think, this cannot go on. We cannot keep eating raw foods and being cold all the time. So who will go to the abode of the gods and bring fire back to us? And some of the bravest warriors had tried doing that and failed. And they sent the donkey to do that, and the donkey had failed because every time he tried to catch the sun behind the next mountain and the next mountain, the sun was always hiding behind a mountain further back. And they didn't know what to do until the Tlacuache, the opossum, was sitting in his little wooden cage. And the opossum said, I will do it. Let me out of my cage, and I will bring fire back to you from the gods. And the elders told the Tlacuache, are you sure? You are so small and so fragile. And Tlacuache said, yes, I am not afraid of death. Let me free, and I will do it for you. So they let him free, and Tlacuache started his long journey to the place where the gods lived. And he walked for days and days to the east, trying to reach the sun. And on the third day, he reached the moon at nighttime. And he started talking to the goddess of the moon. And the moon told him, what are you doing here, little Tlacuache? And Tlacuache said, well, goddess moon, I am trying to reach the place where the gods live to get fire from them for humankind. And the goddess of the moon said, I have some beef with the god of the sun. He banished me to the night and the darkness. So I'm going to help you, little Tlacuache. So the goddess moon cried, and when she cried, her tears hit the ground, and out of the ground sprang up some nourishing plants that the Tlacuache could eat and carry on his journey. So he carried on his journey, and on the fifth day, little Tlacuache reached the place where the gods lived. He reached the abode of the god of fire and the god of the sun. And he saw that the old god of the sun and fire was sitting in his cave by a fire on the ground. And the old god of fire said, who is there? And little Tlacuache said, it's me. It's just a Tlacuache. I'm just a messenger from humankind. Please, god of fire, please don't harm me. I just request that you let me pass the night here, and I will do you no harm. And the god of fire said, okay, you may sleep here, but don't touch anything. So little Tlacuache made as if he was asleep. And eventually, little Tlacuache heard that the god of fire himself was asleep. So he stood up quietly and went to the fire and grabbed a blazing piece of charcoal, and grabbed it with his tail and wrapped his tail around the blazing fire and started running back to the place where humans lived. Right? And he ran and ran and ran. And then he saw behind him, and there was this wall of rocks and fire crashing down of him, because the god of fire is also the god of the volcanoes. And he was chasing, the evil god of fire and the sun was chasing poor little Tlacuache as he ran with the blazing charcoal wrapped under his tail. And little Tlacuache eventually leaped, and the god of fire grabbed him and threw him far, far away, being sure that that would kill the poor little Tlacuache. But poor little Tlacuache was stronger than that. And he eventually reached the place where humans lived and gave them the blazing piece of charcoal. And the elders in the village said, "Oh, Tlacuache succeeded. He brought fire back to us." So eventually they nourished him and cured his wounds and cured his poor little burnt tail. And that's how humankind was able to obtain fire, because the little Tlacuache brought it for them from the gods. And this is the story of why Tlacuaches don't have hair on their tails. It's the traditional Mexican story of why the Tlacuache doesn't have hair on their tails. So Tlacuache is the Mexican Prometheus, right? Bringing fire from the gods. You will see why this is relevant to evolution in a second. Evolution is a really old program. Even before we started writing evolution back in the 2000s or late 99, the very first calendar application we wrote for GNOME, we did it in 2 weeks. When Miguel and Arturo and myself were back in university, we said, we're going to write a calendar program in 2 weeks, right? Because back then, there was a budding standard called vCalendar. So Miguel wrote a parser for vCalendar. I wrote the GUI using GTK, and Arturo started writing some of the week and year views for the calendar. And Arturo had already worked on a contacts program called GNOME Contacts or something like that. And it used another new standard back then, which was called vCard, which is still used to these days. Some people had written 1 or 2 random email readers for GNOME. This is what the first version of GNOME Calendar looked like. You can see, this is GTK 1, right? You can see all the motif-like bevels, our first set of icons. We didn't have symbolic icons back then. This was the first GTK calendar widget. This was a GTK lists something. This was a custom widget we wrote for the calendar. It was very, very basic. This is Balsa, one of the first GNOME email readers. Again, this is GTK 1. We had our original icon set down there. It was really simple, didn't work very well, but you know. Some friends started a company called Helix Code, which later got renamed to Ximian. And that's where we wanted to write a new groupware suite, because groupware was the big thing back then in the early 2000s. Customers had told us that one of the big reasons why they couldn't move from Windows to Linux was because they needed Outlook. So we set ourselves a mission to clone Microsoft Outlook. And that's why you see evolution, and it looks exactly like Outlook looked back in the 2000s. We rewrote the calendar and the address book from scratch for copyright reasons, because Helix Code wanted to own the copyright for that. But it was still GPL software, so not much of a problem there. vCalendar had been phased out by then. There was a new standard called iCalendar that's still in the RFCs that they are still used to these days. vCard is still around. People at the company started writing a new email client based on a library called Camel. And Camel was itself based on the Java Mail APIs, which were fairly good and fairly comprehensive back then. And we were very, very keen on having syncing with Palm devices. The Palm devices were these things. Before smartphones, there were these devices called the personal digital assistants, PDAs. They were fantastic. They did not connect to the internet. You had your calendar, your to-do list, your appointments, no distractions, a few snake games and Tetris. They were great. And every business person wanted one of these and carried it in their pocket. And it was very important to be able to sync your calendar on this thing with your calendar on the computer. So there was a lot of effort put into evolution to do that. And sadly, these are no longer around. Smartphones appeared in the mid, 2000s. So we moved on to that. Development was very different back then. The concept of continuous integration, the concept of building your code after every change to see if it still worked, was new back then. It was basically invented at Mozilla by Tara Hernandez. She wrote one of the first CI systems in existence called Tinderbox. Mozilla had the problem that they had to build the Netscape. Well, it was not Mozilla back then, it was called Netscape. Netscape had the problem that they had to build their browser code base for Windows, Linux, Solaris, IRIX, Mac OS, for many, many platforms, and things were breaking all the time, and they needed a way to ensure that the build was always working. So Tara wrote Tinderbox, and over time it became a platform not just for doing builds, but for integrating development tools. So Bonsai was a tool for navigating source code repositories. LXR was a tool for navigating your source code based on, you could click on a function name in the source code and it would take you where the function was defined. So it was a tool for navigating very big code bases more easily. The only revision control system we had back then was CVS, which is really terrible. It was really primitive. And we were using the early versions of auto tools for GNOME and Evolution. So you can imagine just how terrible all that was. And a typical day in development was you would update your source code from upstream. So you ran CVS update. But you might want, CVS let you update individual subdirectories, not the whole source tree, like we're doing with Git nowadays. And since things were always breaking because we didn't have a way to ensure that the code always compiled, it was very common for people to start their workday just by updating the calendar source code, or just the address book source code, or just the mailer source code, trying to build just that little subdirectory, install the new libraries, and see if they could still get it working, because everything was breaking all the time. GNOME was breaking its APIs all the time. We didn't have stable APIs or anything. And Tlacuache brought fire from the gods to humankind, and we thought, or I thought, being the Mexican in the team, I thought that we were bringing Outlook to mere mortals, right? So we wanted to, or I wanted, Miguel and I wanted to have a code name for the data storage part of Evolution, call it Tlacuache. But the English speakers in the team, told us that the word Tlacuache was too hard to pronounce. English speakers saying about things being hard to pronounce. And they wanted to call it another animal name. And we had a very colorful Australian in the team, so we ended up naming things in Evolution after Australian animals. You'll see that in a second. And now let's move on to what I really want to talk about. Evolution is a really old source base. Evolution Data Server is the part that people are mostly interested in nowadays because it's still used for the new applications, GNOME Calendar, the system-wide contacts, the system-wide accounts. And Evolution Data Server is in this unfortunate place where many of our old infrastructure libraries that are written in C all stand. And they all come from the time before we had CI. They come from the time before we had source code sanitizers. They come from the time before we had really nice tools for keeping large source spaces in check. So the first task I'm doing is to add the basic toys to Evolution's CI, which up until recently was very, very basic. It just built the thing and ran the test suite, and that's all it did. So let's look into these things. This might be old news for long-time maintainers, but my purpose behind this talk is to show newcomers that these tools exist, how they can be used, and maybe you can learn a thing or two about why there's so much previous work to be done before we modernize the source code. This is a test coverage report for Evolution Data Server. A test coverage tool, what it does is it runs your test suite and tells you exactly which lines of the source code got executed and which lines did not get run at all. So very, very high source code, which has a very, very high requirements for reliability, empirically is seen to have over 90-something% coverage in the test suites. That means that when the test suite runs, over 95% of the source code gets exercised by the test suite. Evolution Data Server is not in that good position yet. Some of the source files are not tested at all. Some are only partially tested. So we have some work to do there. This is in contrast to other code bases which also have test coverage. The left, we have the test coverage report for glib. Glib is fairly good. It's at 80-something%. librsvg is at slightly better. It's almost 90%. And this is not to gloat about the state of librsvg, but it happens to be code that is much easier to test. You know, librsvg just takes SVG files and renders them into pixel data. So it's very easy for this thing to have SVG files which exercise the library, and we compare the output PNGs to reference data. So it does no input-output, it doesn't depend on the network, it doesn't connect to any services. So there's not much that is hard to test there. However, in glib, things are harder. In glib, testing the GI repository compiler, which has very, very little coverage, is harder because to do a lot more previous work to be able to exercise all that source code. If you want to exercise all the I/O paths in there, you need to do a lot of work. And that's also the case for Evolution Data Server. You know, how do you test connection to a Microsoft Exchange server in the test suite? Do you spin up Microsoft Exchange in your CI? That's really hard to do. So it doesn't do that. So we need to find ways to decouple the algorithmic code from the code that is hard to test. So a test coverage report tells you what code gets executed when you run the program or when you run the test suite. You can do different things with this. Once you drill down in the coverage report, this is what you will see. This is one of the source files in Evolution. And the test coverage report tells you the lines that got executed are in green, and it tells you the number of times. You can use that as a cheap profiler. The lines that are yellow have branches in them. decisions. And the lines that are yellow means that one of the conditions was tested, but not the other one. For example, in this line 153, it's yellow, and it means that the statement, if not file, that always evaluated to false, and the code went through to the next line. It means that the go to error, malform, blah, 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 which is in red, that line never got executed because that condition never jumped inside the if statement. So if we wanted to test the go to error, malform URI code path, we would need to set up a condition so that the if not file is true, and it would jump to the other case. Likewise, we have no test case where a file has, I don't know, an invalid URI or something. So the temp file is always able to be created. So this code, these two lines of code are never being tested. So we have to make a decision. Do we want to test them? Do we need to test them? Do we need to test that error propagation works correctly? In that case, things to think about. Branch coverage is the thing that tells you which of the branches were taken and which were not. So you can make a decision about whether you need to have finer grained data in your tests to see which ones execute and which ones didn't. So over there, it means that maybe priv is dirty was true sometimes and false sometimes, and writable was true sometimes, false not other times. So we see here that we did go into the if statement because the lines inside got executed, but we didn't test all the combinations of those of the is dirty and the writable flags, right? So what can you use test coverage for? You can use it for multiple things. If you are new to a code base and you don't know where anything is implemented, but you can actually run the program by hand and click on its controls and everything, you can build the source code with test coverage running, with a coverage report running. You can run the program, click on things, run a feature, look at the coverage report, and the lines that are green will tell you where your functions are implemented from the user interface. So that's one way you can use it. The other ones, which is the one I just showed you, is test coverage. Which of my code gets run by the test suite and which one is missing tests? You can use it to determine the comprehensiveness of your test suite. If you have different compile time configurations, for example, are you building for Linux? Are you building for Windows? Are you building for BSD? Is there some if-def that only happens with a certain build time configuration? Are you enabling debug code in if-defs? Are you disabling them? Are you trying some optimizations gated by compile time options? If you want to ensure that some of those compile time configurations actually work, you can ask the coverage report to tell you if those lines got executed or not. For example, in librsvg, it builds for Windows. It makes its best effort to run correctly on Windows. But I have no way of ensuring that myself. So I just let the CA run on the Windows runner, and the coverage report tells me which of the Windows-specific code got executed, and I have to make a decision. Can I fix this? Is this like purely algorithmic code that only runs on Windows that I want to test or not? So it lets me make that kind of decision. We already talked about this. Which compile configurations you want to test? You can make decisions. Can you set up virtual machines or other ways of running your code in other platforms? Can you set up CI runners for things you actually want to test? What code do you think you are sure that gets run by users when they are going through your program? versus what gets run in test suite? Do you want to be able to drill down into other parts of the code that you are not sure if the users are testing or not? And the thing that always happens when you first set up a coverage report is you start finding algorithmic code that should be easy to test because it's just there. It depends on no I/O, no network, nothing, but it's not being tested. So you say, oh, I can add a test easily for this. So you go and do that and improve your test coverage. Then you figure out that some other code is not being run because it depends on networking, I/O, external services. So you have to make decisions. Do you set up a mock service so you can test your code? Do you set up mock data to feed into your program? Do you simulate I/O errors somehow to test your error paths? Do you want to make some error paths are absolutely correct and well tested? Are some others just supposed to generate an error message which you basically ignore most of the time? So it lets you make that kind of decision. I was telling you that we had a very colorful Australian programmer in the team, one of the authors of the mailer part of evolution. So we started naming the components in evolution after Australian animals. So instead of tlacuache, we had a wombat, which is not hard to pronounce at all, right? But wombats are really cute. Anyway, so that's not a bad change. Trivia point: wombats, when they poop squares. They poop little cubes so that it doesn't roll down wherever they do their thing, and other wombats can find each other. It's really strange, but it's the only animal that poops little cubes. Anyway, address sanitizers. The next thing I added to Evolution's data servers CI was a pass with ASAN, address sanitizer. This is absolutely vital for C programs, because C is a memory unsafe language. It means that you can have invalid pointer dereferences, null pointer dereferences. You can have out-of-bounds accesses to buffers, which are really dangerous for attackers. Use after free. All the memory unsafe things that we know C lets us do very easily. The address sanitizer feature can help us find that. Using it is really easy. You just compile with those C flags, and it lets the compiler instrument your code. It lets the compiler add extra checking to your source code so that when you run the program, it will tell you if you made a memory safety error or not. It replaces malloc and free in the runtime so that they get checked versions and tell you about errors. The important thing about sanitizers is that they are runtime things. Your code needs to run for address sanitizer to be able to find errors in it, because it's doing checkings at runtime all the time. So if you look into your coverage report and find a big section that is not being run, address sanitizer is not telling you about any potential errors in there. This is another reason why having a coverage report is useful, because you will know which parts the sanitizers are able to reach or not. So this is a fairly complicated error handling chunk of code, but it's not being run at all. So we don't know if it has memory safety bugs or not, right? There's another sanitized for undefined behavior, like when you in C, whether it's valid to shift a value left or right, a numeric value left or right depends on the sidedness of the value. So UBSAN will tell you if you are doing that wrong. C doesn't let you catch integer overflow easily, so you have to run it through a sanitizer. Attackers love the integer overflow to construct exploits. C doesn't tell you when float to int conversions overflow, so sanitizers help you catch that. One of the other parts of evolution is Camel. Camel is the mail library. It's the library that parses emails, connects to email servers, IMAP, POP, that sort of thing. And it's called Camel because camels, just like the library, is able to go through very long distances without food or water. The other toy we have in CI is a static analysis pass. Static analysis happens at compilation time. Your code does not need to run, but static analysis can catch many errors for you. So, for example, it will tell you of some unused code. This is all CMake stuff, but for example, up there it says API argument with non-null attribute pass null, so that's definitely an error. It means that in some parts of the source code, one function is annotated to say this function must get non-null parameters, but it's being fed a null. So it tells you exactly in which conditions that happens. Down here, it detected a memory leak because it saw that you didn't free something that you just allocated. Stream handling error means that usually in C, you forgot to check an error before calling an IO function. Or after calling an IO function. So, for example, this is one of the stream errors. The static analyzer looks at your source code at compile time, and it tells you, okay, if the code gets to this point, and we call on line 1308 there, and we run fgetC, we're getting the result of fgetC, but not checking for errors. So it tells you, oh, here the position in the file might be undefined if you forgot to check for errors, so you need to do that to do it correctly, right? So why do we go through all this trouble before starting to fix the source code? Because this is infrastructure code. We have many infrastructure libraries that are written in C from years and years ago, before all these tools became generally available. And we need to keep infrastructure running and make it as correct as possible. The C language does not make that hard at all. We've been thinking of renaming it to the CVE programming language. So these are tools that help you clean up a code base, you know. We all know that untested code means broken code, so if you want to flip it around, you'll remember your discrete math way of flipping that around. It means that working code implies tested code. So you can do manual tests. We had QA teams back in the day, and we paid those people to run all the functions in the UI trying to exercise the code. But nowadays, we know it's much cheaper to have a test suite that you run on every commit. But how do you know what's being tested and what isn't? You run a coverage report, you run an analyzer, a sanitizer. And curiously, even though we have Australian animal names in evolution, we don't have any koalas, we don't have any kiwis, we don't have any kangaroos. And I just realized that it was not intentional that we don't have any animals that start with K. So, something to think about. And that's all I have. Thank you.
Thanks, Federico. Question for you. Most of these things that you pointed out are for legacy C code bases, for the profilers and the analyzers and things. With librsvg, do you have equivalent Rust? I mean, you obviously don't need memory analyzers because it's a memory-safe language, but do you have equivalent profilers and analyzers that you run on that test suite?
Is your question if these sort of analyzers are present in Rust code? Or?
Yes. Yeah. Are there equivalent, you know?
Yes. In Rust source code bases like librsvg, if you're using the safe subset of Rust, it guarantees that you will have no memory safety errors, so you don't need something like ASAN there, because those kinds of bugs cannot happen there. There's no null pointers, there's no invalid pointers. The the programming language does not let you reach a state in you can dereference an invalid pointer, right? You can get those if you're using the unsafe part of Rust, and there's checking tools for that. There's a tool called Miri, which is, well, it's a compiler thing. It runs your code through special analysis to see if all the combinations let you reach an invalid pointer, things like that. So there's tools for checking that in unsafe Rust. But the nice thing there is that Rust code bases have usually very small chunks of unsafe Rust within them. So most of the source code is safe, and you have these little chunks of unsafety, which is where you really need to pay attention. But you don't need to pay attention to all the source code, which is what you need to do in C. You need to run carefully through every line, right? And for static analysis, the Rust compiler does a lot of static analysis all the time. That's how it does the borrow checking. That's how it tells you this condition should not be reachable at compile time. So it tells you, it's able to tell you a lot of that. And the people who are doing work for high reliability Rust, like the people who are trying to get Rust validated for aerospace and that sort of thing, they have special tooling to check your code even harder, basically. Thank you.
So the next presentation will be by Emanuele Bassi.
Right. Give me a second. second, sorry. Sorry? Give me 1 second. Because of course, stuff breaks at the very last minute. Yeah.
We are still,
Yeah.
according to the timetable, the time hasn't even started for you, so it's fine.
Right. Okay. Oh, if you want to. There you go.
Hello, everyone. We are going to continue with our next presenter now, Emanuele Bassi, and he's going to talk about some more governance.
Hi, everyone. Yeah, I got hit by the curse of the presenter. Sorry about that. So yeah, I'm Emanuele. I'm going to talk to you about some more governance. I briefly toyed with the idea of calling governance will continue until morale improves, but it was a little bit too on the nose, to be honest. It's been a year. It's been a year. Last year, I gave a presentation about technical governance in GNOME at GUADEC. It was, I was pretty sad because I thought, oh, I'm going to give a presentation that is going to be absolutely contentious and everyone is going to hate me, or like torches and pitchforks and stuff like that. And in reality, what happened was that everyone kind of agreed. That shocked me to my very core. I gave the presentation where I outlined the mostly lack of technical governance in the project. And it gave a few ideas on how to address this problem using other similarly sized, similarly aged free and open source software projects. And after that, I published the notes, which hit all the regular places. And then I opened a topic on Discourse where I hope to get more feedback. I got useful feedback after the presentation, but then I expected more feedback. As I was saying, I was shocked because the presentation was meant to be slightly contentious so that people would be open to telling me how wrong I was, because that's how stuff works. And nobody did. That's not how stuff should go. So in reality, what I got was good stuff, valuable feedback from people. Everyone agreed that technical governance had to be improved in the project. A lot of people agreed that teams and special interest groups were a good solution to that. Share responsibility was a good thing. And more importantly, I actually got some level of commitment from people, which was absolutely unheard of. The idea of proposing a technical governance so that nobody would be responsible for taking the project on their shoulders and dragging it, then dying because a single person had to do that work, would have been completely on point for GNOME. Luckily, it didn't happen. Sadly, I also got less good stuff. There was a slight hyperfixation with my rant about maintainers. people decided to just stop at that particular point. I agree. My theatrics and my kind of framing of the issue didn't help, and I know, but it was mostly for comedic effect, and people took it like seriously, like I was going to set up guillotines and like start executing maintainers in a public place, which was, yeah. The other less good stuff was that we have very few volunteers, we have very few people working on this, which means that people were looking at other people to unblock the issue, and they were waiting for somebody to come along and tell them what to do. Again, extremely on point for GNOME, but honestly, I thought we were going to like get over this pretty quickly. Instead, the point is that, yeah, a lot of people want a new technical governance for the project, but they really don't know where to start, and they honestly want somebody else to tell them what to do. Figures. Imagine if we had a governance that allowed people to take matters into their own hands and make stuff happen. Like, yeah, we'd have to jump back with our DeLorean to 25 years ago and set up a governance system for the project. Stop people in the past. Like, go back and tell, and give the sports almanac to Miguel and Federico and see what happens. So at this point, it's time to do something about it. Well, this point, like 12 months ago, was the point of doing something about it. But the next best day is tomorrow. So let's start with the least controversial bit of the proposal, like setting up teams, special interest groups. So thanks to Alan over there, we have rules now of what is a team and what was an active team or was an inactive team. Inside the handbook, we have an entire chapter about that, which is great because it allows us to define not just this is an active team, it does things, how do you define that, but also gives us the ability to say, oh, this team is inactive and probably needs to be retired, if not revived. So it gives us a little bit of leeway on figuring out what are the things that are needed to remove a time sink that is, let's try to revive this team that has not got any contributors in like 5 years, which is one of the many problems that we have, to be honest. It also defines the places where people should collaborate. Like we have team spaces under GitLab. We have an entire team category under Discourse. We have a namespace inside Matrix. Matrix is its own like kind of worm, so I'm not going to touch that now. I'm going to touch it later on. But yeah, the GNOME infrastructure has a ton of like room for growing teams and things like that, which is great. So after the GTK Hackfest in February, well, before that, but during, I started like collecting people like Pokemon and basically just trying to jumpstart the idea of a platform team. So anybody that works on the GNOME SDK, like any platform library, gets to be on the platform team. The overall idea is not just people reviewing patches, reviewing merge requests, like triaging bugs, but mainly collaborating in a shared place. This is kind of the point of a team. The point of a team is not going around and doing like triaging together or reviewing each other's code. That is also a thing, but the main point of a team is to have a shared place to talk to each other so that stuff happens and everyone is on the same page about it. There is no chance of somebody going in their own direction, and 6 months after that, they come out and say, oh, we found a way to replace GTK with another toolkit. That would be insanity, because it breaks the social contract. This stuff needs to be discussed beforehand, before going around and doing your stuff. Otherwise, you're just playing, and yeah, that's fine, but it's not how you build a platform. So this is why the most important thing about the platform team is not just the code, the shared code being reviewed and being committed, but mainly is the monthly planning session that we do on the last Friday of the month, where we have a call, an hour, with an agenda, we go through it, and basically we talk about stuff. We have a problem, we have a design issue, and we talk about it. And the other thing that we do when instead we have a complex topic, we start up a design meeting, where basically we do a deep dive of time-boxed an hour of a deep dive on stuff. 2 months ago, we had a deep dive on scrolling widgets. The existing API is bad. It's also a legacy from GTK2. We need a new way of doing things. And the problem, space is so big that you need to have a bunch of people talking to each other to identify the issue before even starting to go off in a branch and doing some code. So the goal of the platform team is, whenever somebody is contributing to the core library, a new feature, a new setting, a new widget, a new API, it doesn't matter what, it doesn't matter how big, you come to the platform team and you talk to us. If you're inside already at the platform team, you know what to do. If you're outside because you're a new contributor or you are interested in something for your application, you come to the platform team. You talk to us during one of the planning meetings, or you open an issue and you do things. You want to discuss introducing API, deprecating the old API, come to us. Talk to us, basically. And how you do it is you use a label on GitLab. It's very simple, Steam platform. And that label gets used to identify items to be put on the planning team agenda, on the planning agenda for the platform team, so that we can discuss it during our planning teams. We can talk to you directly on GitLab. We can talk to you on Discord. At some point, we will have a matrix room for it. The matrix situation is kind of iffy because of the new moderation policy servers things. Once it gets more stable, we will be able to create new rooms under the team's namespace, so people will be able to join that instead of having to join GTK or newcomers or, I don't know, GNOME hackers. Having a dedicated room is going to be easier to narrow the discussion, the focus of the discussion. There's a platform team project webpage that has everything, all the details on how to add an item to the agenda, when we do the team calls, the minutes of the previous calls. That's perfectly fine. And yeah, you can join the planning meeting. It's open. It's not like a private meeting. The room is open to everybody. And the next step for the platform team are recording the team ownership in the dope file so that we don't get single people there in the dope file for 10 years that haven't committed to the project at all. So that the entire team gets ownership of the entire platform. And yeah, more membership, more people get invited, mainly because if we remove personal responsibility for a specific project, we share the responsibility, it's easier to invite more people in. So we can get also support roles, like keeping the agenda, take notes, so that If I have an accident and I disappear for the rest of your lives, the team goes on and doesn't require me to like exist for the end of time, until the end of time, which I don't plan to be honest with you. Similar to a platform team, the bindings team is kind of important, because GNOME is not just a desktop platform written in C. That would be kind of bad. It's consumed by a lot of programming languages, through a lot of programming languages. And we have a lot of bindings. And a lot of them are not even, a lot of them are not even hosted on GNOME infrastructure. Like GTK-RS is on GitHub, GearCore is on the C# bindings are on GitHub as well, Java GI is on Codeberg, I think. Peel is on personal namespace on GitLab. So it's very heterogeneous. And just like the platform team, people are working on libraries or even applications with plugins, and they have doubts about their API, how is it consumed in other languages. So you need to be able to ask people that know this platform how this works. And the bindings team is meant to be doing exactly that. But also sharing information, because a lot of bindings have similar issues and they've been solved in similar ways, but they cannot be abstracted away into the GeoBJ introspection library, because it's like language specific. But the solutions may be language agnostic. So if you're writing a binding, that is a great place to ask questions. Same thing, open a label, come on discourse. The web space for the bindings team is going to be up soon. I have a template for that, so it's fine. Sadly, the meetings have been spotty, but they will come. And then we have other teams in the work. The documentation team either needs reviving or needs to be put out to pasture. There hasn't been anything going on in the documentation team except for when I revived the help.gnome.org website, which requires forking half of the documentation infrastructure anyway, which is hosted on GitHub. Other problem. The accessibility team that Sophie proposed should go because it's important. The accessibility team up until now was basically the ATSPI maintainer and the Orca maintainer, and they are really hard to get a hold to. So having a bigger team should help. And yeah, if you have a team, if you want to propose a team, go ahead. Of course, if you propose a team, you have to be aware of the challenges, like maintaining momentum, so that once the team is started, it can continue on its own, you have to deal with things like components and people coming from a disparate set of circumstances, like across the, not just across time zones and but also infrastructure and things like that. You have to be aware of the secretarial duties of keeping an agenda, keeping the minutes, keeping the meeting on time and also on target, because it's super, super easy to get a meeting completely derailed after 10 minutes and go into a weird, hyper-focused discussion that basically nobody cares about except one person or two. So if you want to build your own team, you have to follow the rules on the handbook. You create a space, come to me if you want a template, and then the important thing is all regular meetings and publish their agenda so that people are aware of, people can jump in, help you out. And use the GNOME infrastructure because it's there for a reason. So I have very few time left, so what's left? So like Hatsune Miku said, we do these things not because they're easy, but because we thought they were going to be easy. The steering committee is a big thing. It's like, we are building the thing. We're building the substrate so that the steering committee can be built upon without like dying after 6 months. There are very open questions like who gets to be on the steering committee and for how long? How do we avoid groupthink so that we have a very small subset of people steering the project in a direction that the rest of the community doesn't care about? Whether or not it's a steering committee for decision making, like the Python Rust like model, or arbitration, like the Debian Technical Committee. Arbitrate technical issues between teams. Ideally, both is good, but it requires two very different mindsets. So it needs to be able to cope with this large remit. The other bit was the RFC process. In all my communications for the past year, I've been extremely clear that I was not going to go into that because there is nothing that trips a bunch of nerds like rule lawyering. And also, there's nothing like bureaucracy that trips up nerds, because nerds really hate bureaucracy, except the one they come up with themselves. So they love that, but if somebody else comes up with, So ideally, the simplest, like least bureaucratic way is to have a template, you fork the repo, edit a file, open a merge request, discuss, merge, done. You want a consistency for all the teams because you don't want to have like a bunch of processes, one for each team. And maybe you want a domain separation between like project and team RFCs. So team-specific changes or changes that affect multiple teams and a larger area, surface area of the project. And you want somebody that deals with the enforcement and tracking of the items. Shout out to Sophie, who's a GNOME fellow now, and she, definitely, because she is going to be dealing with the RFC process. I'm going to help out, but she is going to be the one. So great. And yeah, to sum up, there are new teams being established, which is great. We have a platform and bindings team. We are working on a steering committee and the RFC process. There's a lot of challenges ahead, and we need your help, because otherwise this thing is going to die in 6 months, and we are going to go back until the GNOME project is basically dead. So just to close on a positive note. So if you have any questions, talk to the cat. And I want to thank my employer for allowing me to come here to talk to you beautiful people. So yeah, if you have questions, well, what the hell? Yep.
Any questions from the public?
Questions. Come on.
So how do you avoid the problem where, say that you started a team and one person is always like responsible for holding meetings and keeping notes and stuff, but then that person, I don't know, disappears or just goes on vacation and nobody else has the experience to hold the meeting? And how do you avoid this problem?
So part of the idea of the template for the website is that it also contains the instructions on how to hold a meeting, the instructions on the minutes, on the agenda. So it can be templated. A lot of this stuff is not like rocket surgery. It's very, very simple stuff. I discovered that when I was the secretary for the board of directors of the foundation. It really needs mainly the will for somebody to show up. Technically speaking, you don't need much more than that. One thing that we are still discussing in the platform team is to record the meeting sessions so that it's easier to run like a transcription service or like getting a summary out of the end. Personally, I would never use AI to do this stuff, but yeah. it's possible to do that, like under strict, very strict, like human overview, because AI tends to hallucinate entire section. So if at some point during a team, if you read the minutes that somebody volunteered to rewrite the entirety of the layout system in GTK, it's either going to be Sergey like talking about it, or it's going to be hallucination from an LLM. But the instructions for the process are easy to set up, and people only need to follow them. You don't need a single person. That would be very bad otherwise. Other questions? If we have time.
If I think I maintain a platform library,
Yeah.
should I get into the platform team?
Yeah.
Okay, thank you.
It's very simple. Yeah, if you are a core contributor of a platform library, like you do the releases, for instance, or you are like the most prolific maintainer, or even not, it's fine. Join the platform team, join the meetings, propose things for the agenda. Actually, the more things that are not GTK related happen on the agenda, or the more discussion about it, the better, because otherwise we're going to talk about GTK all the time. And we talk about GTK all the time already. And I would like to have more discussions on other places of the platform.
Thank you very
Right.
much, Emanuele.
Thank you.
So I think we are right on time. And yeah, another applause. Thank you. We have a 5-minute break so we can set up for our keynote speaker. Sorry, apologies. We have the coffee break. Sorry, I haven't had coffee yet, that's why. It's not a 5-minute, it's a 20-minute break. If you're ready.
Yeah, sure.
Hello, everyone here in the venue and anyone watching from home. We are going to continue with our next presentation, which is also our keynote. We are going to let the stage to Thomas Depierre, and he's going to talk about From Swords to Plowshares.
So thank you, everyone, and hello. Today I want to start by talking about maps. So this is a map of London, and I use London because I stole this bit from a friend, he's aware, copyright to Fred Ebert. And this is a pretty precise map, right? You have a lot of stuff here. You can use it if you need to navigate in all kind of small hidden streets. You have the metro, you have everything. It's really, really useful, except if what you need is the 8 of the building, because you are not going to find it there, right? This map is nice, but like all maps, it's wrong, right, in some ways. So it's not every piece of information you can have in there. And that's expected, because if everything was in there, that would actually be the world, and we would not, it would probably be a bit too big, right? But there are other types of map. Here is different maps of London, which is a touristy map made for kids and that want to learn about what are the touristy bits of London. And as you can see, you don't have as many streets. The scale is all wonky because I highly doubt that these buildings are as big as people. And it's even more wrong. Like, it's really, really wrong. The thing is, if you are a kid, or if you're a tourist, if I was a tourist when I was visiting London, this was really wrong. It's also far more useful than the previous map. Because it tells me where things are, where the important place, what the important places are, what they look like, which is nice when you're a tourist and you don't know if what you are looking at is just a random building or actually an old thing you should visit, because that's what happened in European city, right? And it also only shows you the streets that you are probably going to go through as a tourist going between big, important touristy sites. So this is a more useful map, because while all maps are wrong, some are useful to you. And that depends on what you are doing at the moment. The good thing is that's not only true for maps. That's a more general thing you will find a lot in systems thinking, which is that all models are wrong. By definition, they are models. But the interesting bit is not if they're wrong or right. It doesn't matter that much. What's important is, are they useful? Today, I'm going to talk a bit about, in this talk From Swords to Plowshare, about how I moved, and I hope to move some of you, from using only what I call the Swords model to a Plowshare model. The reason I use these names is just because it's a nice bit with this illustration from Magic the Gathering cards for Plowshare, which I would find funny. I'm not really caring about the naming, just a bit. But the important stuff here is not only are these models useful, but also how do we know what useful mean, and how do we build a model? How do we go from facts and things we see and things we would like to achieve and get into a way which help us navigate? Like the map help us know where we go, how we go there, what to see, what to concentrate on, what to focus on. So, I want to preface with a few caveats, because this is a keynote and I have to make it entertaining, right? But I'm also too much in science to not say that I'm going to say lies. So caveat one, I'm going to use terms like FOSS, free open source software, open source. I'm not going to use Libre, but free software. I know there are differences between all these terms, right? I know the room in which I am, I understand, I know all this. Trust me, I know. I've been in the same fight on the internet. I'm going to use them interchangeably simply because it doesn't matter for this topic, really, and because it's easy, and I have limited time. The second caveat is that I'm also going to use a broad language in a lot of other aspects of this. I may be really blunt in some stuff. I may use some stuff where it's bad, with thing. This is for the sake of brevity. Yes, there is a lot of difference and complexity and diversity in open source projects and stuff like that. But here, we are looking at the big picture, and you may realize why I'm talking of big pictures and not detailed anecdotal information. So, okay, now that I made everyone bored and I did also, let's go to the important stuff. I'm going to use yellow get, useful. What does it mean to be useful, right? Because remember, we are talking with models, and models are wrong. If you want to know more about why all models are wrong but some are useful, there is this nicely website done by a friend up there that will dive you into all the research and science about this. So what does useful mean? To get to useful, we need to have some goals. What do we want? What is it that we are trying to achieve, right? And we need to have something that fits in the constraint of reality. Because I love the idea in my youth to have humans in Alpha Centauri. Sadly, it's a few light years away, and that's probably not going to happen anytime soon. Right? So we need to stay within the constraint of reality. And the second thing is, it needs to be within our means. Because even if something is possible physically, like the rules of science don't tell us that we are totally delusional, we need to be able to pay for it, and not only pay for it, but make the world we live in, the society we live in, accept them as something we can do, right? We need to have the means to get them done. Because, there are some things that aren't going to happen, right? I don't think we're going to do some amazing thing like, I don't know, move everyone to Linux next year. Maybe in 10 years. No, probably not. Maybe in 100 years, but not tomorrow. Okay. So what could be these goals? What do we want for the future? And what does the present tell us that it wants? I'm going to be nice here and reuse some and say some really broad things. Society depends on software. And we don't have a choice anymore. Like, the reality is that society depends on us. Your water comes from a plant that is controlled by software, and if it goes wrong, you are going to have a water problem. Your taxes are done like that. What else? Electricity. The cops filling reports. We have had a case recently in France where, due to software not working, a case was lost and a young girl was killed. Society depends on software, and that's sadly the reality at this point. Everything. Even we all use our phone far too much, right? All of us are on a laptop, and it's just for work. Which means that we have a problem, which is that software is built. The way software is built is that it encodes a model of the world, right? When you write your software, you write in code how you think the world is and how you think it should work. That's what software is. We write down what we think it should do. So it's the logic, but it's also the software around the logic of the software, right? It's what can I expect from GK? What can I expect for my for my OS, right? Like random change. Now I need to change everything that uses random, right? What do I expect from the things around me? Like, I think Federico told about moving from vcal to ical, right? Suddenly the API changed, and we need to change our software. And also hardware, right? If you have tried to do anything with RISC-V, you know that. If you have tried to do anything with, I think Microsoft is still trying to make Windows on ARM work. It's still not working really well. Hardware evolved, and we have to deal with it. And the world in general changed. 40 or 50 years ago, if you had built a software for census purposes to get everyone information about the population, you would have probably only have a binary choice for gender. It doesn't mean people were only these two genders before, right? What it means is that the way society and the world looked at it erased that in the way it was important. But when the world changed, society changed, people evolve, and suddenly we discover that our software that is 40 years old and still need to process census data need to deal with, well, far more than that. And that's a good thing, except the software needs to change. So if we base on this, we need software to change over time. We don't have a choice. It's needed because otherwise we get stuck in what was there, and when the world changed, when everything evolved, when the hardware changed, we get stuck with no software, and society cannot run without software anymore. I mean, not well. It means that dependencies, up and down, hardware, downstream dependencies, things that depend on you, or things upstream, or even things laterally that you use but are more living with you, need to change regularly. And that means you, as people that work on the software, need to change it regularly because the dependency have changed, downstream and upstream, and so you need to change your software to deal with that change, with these new things. It means we have bugs, right? Because bugs can be thought as the models you wrote in your software is actually not entirely wrong. It's not the one you wanted, right? And the world told you, hey, actually, no, this doesn't work like you thought it was. And that can be a security bug, right? Like, oh yeah, you thought you were not getting an overflow, and you actually get one because, hey, good luck with compilers. But it can also be features or adaptation, right? Suddenly, I need more genders, and that's important. So what can we say as goal? Well, we can say as a goal for software is that it needs to have capacity for change, right? And a way to think about that, is that what we want is maintenance. Why maintenance? Well, because it happens that that's a word that corresponds to what we're asking. But the other reason is maintenance is because you need people that know the software to be able to change it. I will talk a bit more about that later, but mostly you need that, right? Now, we have a goal, right? All software needs some maintenance. At least all software that impact society, and that's bigger than we think usually, but we'll look at that in a second. Now, let's look at the other aspect, because we want things that correspond to reality, right? We also want to build a model here. And the best way to build a model is to start with, OK, what do we know about the world so that we can build from that? Because we need to account for that at some point, even if we are wrong. So what do we know about reality? A few choice cuts. We know that 70% to 90%, depends how you count and how much you trust the studies, of all software running in production, and I mean all software, is free and open source software. I did not put the links for the study in all this because they tend to move, but I put enough words that you can find them with an easy search. 70% of all software is free and open software. So the reality is open source as one. Proprietary software, as written, doesn't run nearly anything in the world. That's simply a fact at this point. Now, that doesn't mean that there is no one writing proprietary software, or that the software that is constituted of all these free and open software is not sold or presented as a proprietary one. The rate is, if you want to enact change, free and open source software is where you do it. Because proprietary software is so small of a part that it doesn't matter. So there are exceptions to that. There are some areas where you can find proprietary software being still the only thing. They are usually quickly disappearing. The exception I would bring is that, no, I don't even bring one. Like maybe printers at this point, sadly. But even that, I'm pretty sure they're running free and open source software under the hood. I'm pretty sure I saw curl license somewhere in my printer lately. So the other thing is that free and open software is bigger than you think. And that's also true for all of us that are dealing with this all the time and should know that. And we know that, but the scale is so big that we cannot integrate this in how we think easily. I want to be clear. So research by a friend, George Brasher, looked at this. He looked at the data across ecosystem. This is true however you slice and dice it. There are millions and millions of libraries out there. And they are used. This is not just a random project by a student that was abandoned. You can keep them out of the data set, and you still get the same kind of results. The orders of magnitude do not change. Free open software runs everything, and it's bigger than you think. And the way to think about that is sit down and go try to find out all the dependencies you have, or any of the systems you use have. And you will discover quickly that even for systems that say that they, vendor everything, have no dependency, etc., you will end up in the thousands and tens of thousands really, really fast, if not hundreds of thousands. Okay, so our reality is free open source software is everything, more or less, and it's massive in terms of people, in terms of use, in terms of complexity. Okay, now the next thing, we know also that free open software is one person. Nearly every single dependency package, library, call it however you want, when you do the math, and however you slice it, how many things you get rid of in your dataset because you think they are polluting your dataset, is still one person. A project with more than one person is an exception. It's a rarity. It's an outlier that we should cut out of our dataset for analysis. Okay, so what that means is that not only it's one person, which already point to the idea a bit, but we do know that 60 to 85% of free open source software, depending how you count, is a hobby, which means it's done by someone that is not paid or paid really, really a small amount of time to work on it. We have not found in any data set a link between the criticality of the package and library and the fact that the person is paid. So if you combine all of this, what you get is, oh yes, I always forget this one because it's a new one by Andrew Nesbitt. He found that last month. 30% of packages on library, once again, however you slice it, it doesn't change the data, have no maintainers or no known maintainers or responsive maintainers. There is maybe someone we think is a maintainer, but when you try to contact them, there is never a response, or maybe they have not answered to any issue or PR or anything in a year or two. So, reality. The reason we have only one person and stuff like that is that free open software and general software demand niche knowledge and deep niche knowledge, right? You need domain knowledge in all of this. I am a maintainer and a person specialized in float-to-string conversion for some of my hobby packages. I have doubt that anyone in this room even understand what I'm talking about. Or maybe a few, but that's the thing, right? Think about all the stuff you maintain yourself. The reality is there is a lot of niche knowledge you have accumulated over the years. And if someone, a new contributor, coming fresh out of school, know nothing about your domain, has to go deep and work on it, it probably is going to need 6 months to a year just to understand enough to even know what he needs to do. You can go over that by, carving a little chunk of it and giving to them with mentorship and having really precise document of a design and everything. But that's an internship. This is not a contributor that is by full-fledged contributors working by himself. This is not a maintainer. Remember, we want change, and what we want the ability to change. And this ability to change sometimes has to be quick, right? Security bugs come to mind, but they're not the only one, right? Quick change depends on domain knowledge. Otherwise, every time you need to do a change, you need to go in and learn the domain knowledge before you can do the change. Which means that if we did not have people dedicated to every single one of these packages, and remember, 30% of them have no one, then we cannot do quick changes. It's not possible. That can be unsettling, but that's also the reality we are facing. And we are just in reality, not even in model yet. I'm stating fact at this point. Most of them are hobbyists. We know that. We saw that before. Hobby mean free, right? They're doing it for free, as in beer. They're not paid for it, but it also means they do it in their free time. which means a really, really limited amount of resources. From every study I've seen and every discussion I've had with maintainers, a good average is 6 hours per quarter, 2 hours per month, 30 hours a year, approximately, less than that, but it's a good approximation. Some of them will do more, of course, and you will probably remember them. And some of them, and this doesn't count the ones that do nothing, like as I was saying, in the 30% was we do not know maintainers or a maintainer are not active. They are not counted in that. So they are not even dragging back the average here. So the reality is that all our software is of 300% software. All the 300% software, by the vast majority, is written by hobbyists, which means that most of the software that runs the world is run by hobbyists on 6 hours a quarter. Right. I'm going to sleep well at night. So, OK, that's reality. So we have a goal, right? We know we want things to be able to change because society needs that in software. We need our software to be able to change, being for security or for other reasons, like keeping running on not legacy platforms. We also have our reality check of what it means to have people able to make change. It means that we need to have hobby maintainers. And the change needs to be able to be done on the resources they have, right, in the constraint of 6 hours per quarter. OK. So we're going to switch track a little bit and talk about models. What are the models we have for free and open source software? How do we think about free and open source software? Right. So there is a thing that I call the SWORDS model. It's an activist-based model. It's the one it's an historical model for free and open source software. And the idea is that basically you have free and open source software on one side and proprietary software on the other side. And they are fighting for the attention and the use share by customers, by users. So fight, right? We are against the evil. I am on the side of free open source software. I write that on my free time. I'm a maintainer. And proprietary software, so we are fighting, right? The other idea of this model is that free open source software try to build a community of people that will contribute and participate. Contribution can be really large here, right? Documentation, translation, just making people aware, helping them use it, like everything is accepted. But this idea is that free open source is this grassroots movement built from people helping each other and working with each other. Contrary to proprietary, which is just hiring people and making the work, and then we feed it to users. Both can be commercial. I want to try that. I know this is something that is sometimes forgotten and not talked about, but like the idea is not that free open source software is not dealing with money and capitalism and all that stuff, right? It can bring money, can pay developers. That's not something that cannot happen. And I know a lot of people here probably have some aspect of that in their life. And this is a historic model, right? This is even the model that was used historically for a lot of thinking through why we do this, what are the goal of this, right? And this is a model that is basically centered on users' rights and freedoms. Because the idea of free and open software is that we give an out, but also to people outside of the proprietary one, but also just control the machine, right? You can do, you have both your machine, you run your software on it, and you can modify it, you can see it, you know what you are doing. You can know what it's doing, and it's not abusing you. Due to that, this is also a model that is really rooted and linked to digital rights. Rights to transparency, right to some kind of privacy. But we're also seeing recently in stuff around the ability to move stuff, to have some control over your data. And so we see all kind of foundation historically and digital organization that have built around this idea. And GNOME Foundation is one of them. We can think of the Linux Foundation. We can think of the Apache Foundation. It's slightly different. We can see, or we can think of all FSC Europe come to mind, FS Europe come to mind, Free Software Europe come to mind. These are all organizations built around digital rights, and they work with digital rights organizations. This model also makes a lot of sense if you're looking at digital rights or if you're looking at stuff like sovereignty and independence. This is something that is really in light right now in Europe for obvious political reasons. And this is a discussion, a lot of what I'm presenting here come in part from having to talk with policymakers, people from the EU Commission, from European governments. And so this is a discussion that is definitely big right now and has been seized and used by Foundation and Digital Rights Organization to push for more free and open source software using this model in the EU governments. You probably are aware of some of this, but that's a really big push, and that's something we have seen with the EU governments. The tone have changed a bit on that. So, okay. Now comes the test. Is this model useful? Because it's wrong in some aspect, like all model, but is it useful? To be useful, remember, we needed to help us achieve our goals, fit the constraint of reality, and be within our means. And so what does this model tell us about how to help software keep running, as we're saying, right? Well, it has a few problems. What it's telling us is probably we should tax proprietary software to be able to finance the open source one, because that's the one that respects everything, that's the one we want to develop, and that's the one we want to maintain. And that's also the one we mentioned was everything, right? Proprietary software is actually free and open source software. The fight doesn't really exist anymore. It's the same code. Proprietary software is, by the vast majority, written, constituted of free and open source software. If you think of it this way, it's an EE done by free and open source software to proprietary software. You subsume them. Good job. But that means that the separation is not really useful anymore, right? Because it's not like they're fighting, it's the same people. Going commercial makes no sense for hobbyists. A hobbyist cannot and probably do not want to make a business of something that can run on 6 hours per quarter budget. I am not going to be able to sell people a massive amount of commercial software and commercial licenses or any kind of other services if all I can do is run it as a hobby. And if I want to run it as not a hobby, I am an exception. I'm not going to go too deep into this right now, but if you want to talk to me about, we can talk about that. I have a few blog posts about that, and we can go deeper. And same for Foundation. Going commercial doesn't make a lot of sense most of the time because they need to work with this kind of stuff. And also Foundation are here for digital rights, not to make money, usually. It could work, though, going commercial, if we get rid of all the hobbyists. Right? Make everything a non-hobbyist, a paid system. I'm sorry, this is a massive change. This is not within our means and probably not within the realms of reality. This would mean that you would have to pay millions of people a pretty large tech salary, and you would need to build a build system to fund that and find a way to manage and administrate this kind of money disgorging. That's not going to happen anytime soon. I'm sorry. I understand why people may want that. I want that too, but that's not happening. There's too many people in too many different ways. And even if we did that, we still have 30% of this freaking stuff that has no known maintainer, or they don't respond. So getting rid of the OBS is not going to happen anytime soon. So this model is really useful for sovereignty. It's really useful for digital rights, and that's why I still support it. I have a few donations and stuff like that, and I still believe in this. But it's not useful for our goals of keeping society running. If what we want is maintenance of all this software that runs society, this model is not useful. Doesn't mean it's useless, it's just not useful for this. Okay. Little break. I'm going to drink some water, let everyone, digest the big thing. Okay. How do we build a model that will work then? Because we still need to fix this, right? I mean, I don't know about you, but knowing that all our software, all society depends on this kind of stuff. Like, I would like it to be better. Like, I would like it to be maintainable. That's still one of my goals. I want to sleep at night. And so, to build a model, let's go back to reality. So what does reality tell us? Reality tells us that we have constrained resources, right? It's 6 hours per quarter, 30 hours a year, something like that. This is reality. We cannot work around it, because the only way to work around it is to make all this project not a hobby project anymore. And we just say before, that's probably not going to happen. Okay. When you have a constraint or limited resource that is overloaded, that has too much to do, and I think at this point we will accept that 30 hours per year is probably going to be overloaded for some of these projects. There are 4 solutions. This comes from system research. The first one is shared or reduce the load, so that you can do more things at the same time because it's less. You can reduce the quality. Lots of stuff, you don't do them, or you do them less well, you do them faster, you cut corners. Or you can shift work to later. We all know that. That's called making a ticket. Right? And later usually mean never, but that's a different discussion. And 4, you can add more resources, right? You can suddenly, instead of 1 person with 30 hours per year, you can put 2 people, and suddenly you have 30. You have 60 hours per year. Nice, you can do double. This all comes from Joint Cognitive Systems, a book that I really encourage, but that is hard to get these days. Here's the thing. Reduce quality, we already do that. Right? So the reality is that it's not even that we reduced it, that we never raised it. We do what we can with the time we have. And that's not a bad thing. It's just how we get stuff done. That's engineering. Shifting work to later, well, that's what we do all the time. I don't know how many of you have bugs that are, or tickets open for more than 10 years, but I'm pretty sure some of you in this project will know about that, right? Adding more resources, as we saw, we cannot do easily, because that means we move out of hobbyists, and we know that right now maintainers is 1 person, and that's probably not going to change. It's so systemic, it's probably a systemic reality of this system. So we are stuck with shared or reduced load. That's where we need to find solution. Okay, reducing load. How do we do that? How do we do it? Because okay, first of all, what does this freaking mean? And also, what does load even mean here? So what we need to start by doing is understanding load. What does it mean to maintain? And what takes time in maintaining? What's make it take time? And what's eating at that budget? Right. So, maintenance priority. This is not based on data. I'm out of the full fact reality aspect here. This is based on my own perspective and having talked with a lot of maintainers and having interacted with a lot of maintainers over the years. Most important thing, the build system breaks. That's the top priority. Why? Because if the build system breaks, basically my project is not useful anymore. I can maintain all I want, no one can use it. So that's probably the best priority. It's a form of dependency break, but that's not really that useful. But build system is actually a dependency. It's big enough but it's a big enough one to be worth its own category. We are going to talk about dependency break just after, but this is a big enough one that it cannot be only considered as a dependency break. Secondly, is dependency updates, right? Because once again, the world change around me. Upstream and downstream change, and I need to catch up with that. If I write, once again, I'm going to reuse an example from this morning. If I write a calendar application and everyone moves to iCal and I only manage vCal, well, great, no one uses you anymore, right? So we need that change to keep happening. And that's not only for this, it's also for everything, because dependency updates also bring you new features. And also, if you do not catch up with dependencies, what happens is you are left behind, and then you only run on older machine or on the runtime, or etc., etc. So the next priority, and that's from the most priority to the least, right, it's CI and test suites. And I don't mean here only keeping it running, like, CI is broke, we need to restart the machine or something like that. It's also like just having one and expanding one like, once again, if you have looked at any old C project, and C projects are a lot of this free and open source infrastructure that is used everywhere, how many of them actually have tests? Right? Like, and I'm not saying that as a slide to the people, just a reality we're dealing with. And expanding one, because yes, we have some tests. How much does it cover? What does it tell you? I'm pretty sure here most people are used to the fact that you have to expand the test a lot when you get into a new project because you realize that basically nothing was tested. So this is important, and it breaks all the time too, right? A test broke. Why? Well, because one of my dependency changed, and that changed the results of my test. Okay, and then you have the rest. Yeah, the rest is after these three big ones. And the rest will be bugs. This includes security bugs. It will be new features. It will be functional bugs, as in bugs. It will be also like just, you know, syncing and refactoring and all that stuff. All these come after these. Now, we do this if we have time. Now, I have some bad news. We don't have the time for that. If you're on a 30-hour budget per year, the first three categories of dependency break, CI breaks, and test systems already take all your time, mostly. So you move everything to later. So based on this, based on what we know here, what we have said, what I've brought, what are facts, but also what I just offered as anecdotal data information, is we can build a model which I call the plowshare model because it goes on that. We want the same amount of work, right? But we have 30 hours of work and we cannot get out of it. This is our limit. We cannot do more. We want more useful output out of this 30 hour, right? That's what we want, actually. We want people to do more than the limited amount they can do in this time, right now. And what that means, or at least a model I offer for achieving that, is better tools. Because if you think about it, these three big things that take all our time, right? They are basically tools problem. Now, this model, if you think about the better tools, you now need to ask the question, does it fit the reality? Does it fit limited resource with hobbyists? Yeah, tools, there are some things they can adopt, it's not asking a lot of them. Is it within their means and does it achieve our goals? Well, that's a good question. Let's have a look. So the model would be tooling for hobbyist maintainer. And what I mean by that is that tooling that is explicitly designed to work within the constraint and limits and needs of hobbyist maintainers. Because we know that hobbyist maintainers are 50% at least of the code running out there in production. That's the one we need to focus on if we want maintainership, if we want maintenance. So better tool. What do we need? What could it mean? Better build system. No, make is not adapted, even to C. I'm sorry. Auto tools, neither. Masons help, yes, but the ergonomics are still crap for hobbyist maintainer point of view. I'm sorry, I'm not here to shit on it because I love it and I'm trying to implement it in stuff. But the reality is that as an open source maintainer that has 6 hours per quarter to do your things, you are not going to be able to move to Mason anytime soon, and it's probably not going to help you that much. Build systems in general are not built for hobbyists. If you have followed a bit the build system in the past few years, you may have seen Bazel, you may have seen Buck, you may have seen Buck 2, you may have seen, what was it, Pants. I'm probably forgetting a couple others. These are not built for hobbyists. And that makes sense, because the people that pay to build them for their own needs, which are quite different. Most hobbyists do not compile Firefox or Chrome, right? And actually, they don't because they cannot. I'm sure everyone here is aware of the difficulty of compiling Chrome, building Chrome. Build systems are not built for hobbyists because there is no money in that, right? This is not proprietary. The proprietary software, and big software, even like you with Mason and everything, don't have the same needs that most hobbyists. Here's your dependency update. That would be nice, right? That's one of these better tools I'm thinking of. In particularly, like just respecting Semver, there is, if my dependency respects Semver, I can check which kind of versioning it has. Like if it's a patch, I can just update. I don't have to think. And that saves me a lot of time because I don't have to go through my tests, I don't have to change everything, it doesn't break on me. Both for better build system and for easier dependency update, we have tools already existing that try to do this, and that do it relatively well. If you are in Rust, for example, cargo semver check works really well. And if you think that this is a Rust-only thing, I'm sorry for you, but Predrag, who is the guy behind cargo semver check, has a version for Python that just works. It just doesn't want to deploy it and support it and grow it because he wants to be paid for that work and no one wants to pay him for it. Being able to run tests would be great too. Good testing tool for C, please, because remember, a lot of this stuff is in C. Just being able to run tests in C is already a lot in terms of ergonomics. I think it was, I think for LibreSVG, actually, you talked about this, right? Like, just the ability that in Rust, you write your code and then you write a test and you do cargo test and it just runs. That's it. In C, just putting down the harness and getting it to run is probably going to be 30 hours for a hobbyist that doesn't know about it. Okay, so this could be what it means. Okay, does it achieve our goals? Case study, Rust. Let's have a look at how it works. Compiler that is ergonomic. Yeah, I think that's a good description of Rust. A build system that just works. Cargo build, and you get your stuff. You can cross-compile. It just works. You don't have to define everything. You don't have to go through make. You don't have to define targets. You just cargo build. It works. Test framework that is easy to use and integrated. Yeah, once again, that's what we said, right? It just works. You write a test, you do cargo test, it just works. Nothing else to do. Hobbyist adoption. Yeah, I think we got adoption. I think hobbyists look at this and we're like, okay. Because the question is like, we build them better tools. Will they use it? Yeah, I think they kind of adopted Rust. Yeah, I think that's a good story there. I've been a proud member of the Rust Evangelism Strike Force myself. Rewriting it in Rust just happened. Like, I mentioned LibreSVG, but that's not the only one. Everyone is rewriting some stuff in Rust. And that doesn't come from above. Just hobbyists looked at it and say, yeah, if I need to rewrite it in Rust to not deal with the pain of all these bad toolings that I had in C, I'm going to just do it. Right? They even do it coming from Python, or Ruby, or Node, JavaScript. Right? Like literally, there are teams that have been rewriting the toolings of this programming language in Rust because it was nicer than doing it in their own language. Adoption happens. And we also get new tools. So that's an interesting one in terms of achieving our goals. Remember, we want better quality and better output for the same amount of time. New tools written in Rust. And by that, I mean libraries, stuff that help you write better tools, but also tools themselves. I'm thinking of riprep, but I'm also thinking of clap, which is the command line parsing and handling tools in libraries that is used a lot in the Rust ecosystem, are just better than everything else in other ecosystems. Like, riprep is better than nearly everything that try to compete with it. That's just a fact at this point. It's easy to say it's a fact because Burn Sushi released a massive benchmark with explanation of why and how, so it's easy to say it's a fact because he backed me up. And what we see is massive progress in terms of features, in terms of bug, in terms of safety, because time is unleashed from being spent on build, dependencies, and test. Basically, we can maintain more because we don't spend our time on this stuff. So it achieves our goals, right? These models, at least what it offers as solutions, seems to achieve our goals. Now, is it within means? I'm going to use Rust because, once again, it's one of the great tools when I have the data. Case study. Rust, a decade approximately from start to 1.0, which is the point where the inflection point for adoption. Adoption happens over time, right? When you provide a new tool that is better, you do not expect all the hobbyists to use it immediately. It doesn't make sense, but that's expected. Cost is pretty contained. So I do not have hard data on this, but I've talked with a lot of people that have been the managing chain at Mozilla at the time of the Rust team was there. And they estimate that the cost average over the over the whole time it was there was approximately $1 million per year. This is not nothing, right? I don't have that money, would love to, but it's achievable. This is not boiling the ocean. 10 years at $1 million, this is a budget that can be offered to policymakers. Right? It's a budget that will make sense. 10 years is a bit long. It doesn't fit into the usual election cycle, but it does make sense for policymaking. The other good news, and that's also a case study from Rust, the research already exists. We are not, if we want to build better tools, we are not going in there blind, having no idea what to do. Right? We are not starting from scratch. There's been a lot of research on how to do it better. If I remember correctly, Graydon Hall, the guys at launched Rust, as in his own presentation, also regularly in his blog posts, keep pointing out that there was nearly nothing new in Rust. Everything in Rust came from research, and a lot of it comes from the 70s. The most early, like the stuff that come from later, I think the latest one is probably Cyclone for some of the board checking stuff, and it comes from the early 2000s, like 2001 or 2002. Like, we know how to do it. Like, the research exists. We are not going from scratch. We do not have to boil the ocean. This is a really limited investment needed. It's all that is needed, and that's a big all, and I know that. It's like if I was saying just, is bringing this kind of tools and knowledge to industry, building the tool in a way that the industry can use, and that fit the needs of the hobbyist maintainers. That's a pretty safe bet, because we know what to do, we know how to do it, it's just engineering. It's probably going to take 10 years for each project, but that's doable. I did not use it, but another good example would be TypeScript, or the language server protocol, or Visual Studio Code as an example. We know how to do it. We have example. I could also talk of log files. I could talk of all these build tools that languages use now. Like, we know how to do it. Even for C. You can do it for C, I promise you. It may need some rethinking and some feathers that need to be ruffled, but you can. So it's a limited bet. It's a relatively safe bet. Even if some of them fail and do not get adoption, we have not spent that much. And the other good news is that, like, there is a lot of hobbyist maintainer, a lot. So any of these bets that works are going to unlock amazing stuff, and that's what we saw with Rust. Right? It's a systemic effect. Okay, so the model become tooling for hobbyist maintainers, right? That's if we want maintainership to get better, if we want security bug to be fixed, if we want all this stuff, like society, to adapt to this change and to get better and not to depend on bad things, what the model tells us is that what's useful, what's a good way to think, and that's not the only way, but it's useful for this particular purpose, is tooling for hobbyist maintainers. And you cannot get rid of any of the aspect of this. That's what I call the plowshare model, because that's the same stuff. When you look at agriculture, the moment you gave farmers better tools, they produce more food with less human time spent on it. That's the same thing we want. We have a limitation of the amount of time we spent on it. Well, then, let's get better output on better things and things that matters more to us as society out of this time. This was from Software Plowshare. I am Thomas Depierre. You can find me at softwaremaxims.com, which is my blog, where I've posted amazing bangers like I'm not your supplier. But mostly, I want you to think about this model, and if you are interested, I will take some questions and try to answer them. Thank you very much. Before I go into Q&A, I have some rules. Comments are okay. I know, you don't expect this one. I yap enough to turn any comment into a question. That's not a problem. But attacks on the data and facts need to respect these rules. You can attack the methodology, but you better be informed about the methodology that was used. Okay? Because otherwise, we're just going to spend everyone's time for nothing. Or you can attack with data, but it needs to come from strong studies and reliable stuff. I read a lot of scientific study and research for my free time. I am used to attacking methodological and problem on this, so you need to come with strong stuff. Second thing is anecdotal attacks on what I just said, on the model and how it works, will be countered by anecdotes or be ignored. You are warned.
So, at your own risk. Questions, comments?
There is one, I think. Everyone else wants food, which I understand.
I'm a little scared to ask this question, but it seems like the obvious one. What about AI? Like as a software development tool? Or
AI?
Yeah.
Does it help with the three things I pointed to?
Well, it can reduce developer workload.
Does it reduce build system? Time spent fixing the build system? I have seen people try. It usually doesn't know how to deal with it because build system is an atrocious thing for sanity. Does it help write better tests? The experiments I've seen with that have not been amazing. It can help a bit with fuzzers, but that's usually not what you need. And it doesn't help write the harness and stuff because the tools are so bad that even if you use it, it's going to break, and fixing it is not something you're going to be able to do. Does it help update dependencies? I mean, you can try. I have not seen a lot of people try because dependencies are going to touch everything in a strange way when it breaks usually because it breaks the models you had. So I would say whatever is done with AI is nice in the rest, and we can maybe talk about it later, but it doesn't matter. Even if it helps, it doesn't help for the stuff that matters.
I'll maybe leave other people in the room to respond to that because they're better qualified than I am.
Oh, I know. But like, I've not seen, right now, I would say that I will take it as a solution once it offers solutions that are baked, that are offered. Right now, I have not seen any uptick in like hobbyist maintainer output, even the ones that have access with AI. Like we do not see, I don't think everyone here has seen a massive raise in quality, features, or bug fix for open source software yet. You may think of exceptions, but I mean, we are talking the large here, right? We're talking of the 50 to 80% that are done by hobbyists.
Thank you for your presentation. I agree with what you said about tooling, because I am the Damelines maintainer, and I took the maintainership 6 years ago, and it took me a very, very long time to secure the pipeline, the build system, the dependencies update. But I would like to add something. I think that engineering also helps reducing the amount of work we have to do. I will explain myself. I spent about 2 years refactoring the existing code base because actually the Damelines project is very old. It has almost 20 years today. It's been maintained by many people, so many different practices. And so it took about 2 years to reduce this, what we can call technical debt. And so it has been done with the idea of, okay, I had difficulties to understand the code first, so I want that new contributors understood it more easily. So there is tooling on one side, but there is also engineering that we can do to reduce the complexity and the cognitive complexity to read code.
Totally, and that's part of the ergonomics of this tooling, right? Because your programming language and all are also tooling to help with that. The reason I don't focus on that when I talked about this model is because to be able to do that, you already need to have time to spend on it. And what we're seeing right now, I remember 30% of this library do not have a maintainers or one that responds that is active. Like I agree with you, right? As we're saying, you took something that was already, kind of abandoned or left over and all. You are right, and I want that too. I am not sure it will achieve the kind of impact we want right now. But that's definitely something worth, doing more. And I mean, I can think of a lot of Rust people saying that, for example, the compiler helps them, do that kind of stuff more recklessly because the compiler helps you and support you. So I totally agree with you. It would help. I'm not sure it needs to be on the top of the list, but it would help.
Hey, since you're talking about hobbyists primarily as a focus and impacting essentially quality of life for hobbyists, what are your metrics? Like if we're going to experiment with trying to do things that impact, I don't know who the hobbyists are, right? So when you're saying things like, you just said, I'm not seeing the impact of this particular tool in the hobbyists of 50%, 80%, I don't know how you're measuring that to verify what you just said. Because I think all I have is anecdotal, and I don't want to talk about it because I will push back with anecdotal evidence for some arguments. But I want to what is your metric? Right. So I can track the same metric and I can do experiments with changes and prove that some of the things you've said are wrong.
Well, I get you. A few things I could offer. It depends what you want to attack. If you want to attack if you want to know how much we get, how much output, if the output get better or not, you can look at, you can actually go talk to maintainers. I know, like, a user study would be great.
No, the question is, what is your metric?
Oh, mine. Oh, but what do you mean by that? How? Right.
And I want to know what your metrics are.
All right. I don't have a metric right now because the model is not at the point when we can pull a metric out. And I know, but if I wanted a metric, like how much they moan, like how much they complain about it, like what is the sentiment, if you go talk to maintainers, what is the sentiment about the tooling? When they are, oh, this build system broke again, do they cite or like, oh, right, yeah, of course, I'm going to fix
but you've also categorized your maintainers as hobbyists and not hobbyists.
Yeah.
How did you do that?
Oh,
for this entire
paid.
setup, how do you know who your hobbyists are and how are you measuring their sentiment?
So for the hobbyists, it's easy. You ask them, and they will tell you if they are paid or not. That's the study that was done by Tidelift. Keep in mind, like Tidelift probably undercounted the numbers of hobbyists because they are a
Whoa.
Yeah.
I have people who are paid for some work and not paid for some work. So
you can separate by package.
Are you going deeply into what they are paid for and what they're not?
Yeah. Tidelift did that, yeah. It's usually not that much of a problem because, I mean, I'm not saying it's not that much of a problem, but that's an important thing. One of the metrics that is interesting on this is, if you wanted metrics, we could have also metrics on how many of them are abandoned. We could have, like, the reality what we want is better result in general in terms of change. So how fast are the security bug fixed? Like, do people actually have time to look at them? Does the test coverage in general get better? Do we get, like, how long are tickets waitings? We could look at all kinds of things. We should probably also look at sentiment, feelings. How do they feel? Do they feel burnout or not? This is stuff I have not talked about here, but you can find in some of these studies I mentioned, and if you search. Like, but I agree with you that it's underlooked. It's not looked at that much. Another thing you can try, and something I would love to see a better look at, is how fast can you onboard on a project, someone new. And by onboard, I mean actually doing it and seeing how it works. Because there is a lot of company I've been part of, and also maintainers, like a free project, where they tell you just have to run these 3 lines and it just works. And 6 months later, it still doesn't work for me. So there is a lot of metrics you could look at here. I'm not at the point where I demand, when I look out for them actively, but I don't think it would be that hard to find some. Mostly, like, if you think as, and that's anecdotal, but that's also qualitative, right? If you think as an expert that deal with that stuff a lot, do you consider that right now, if you go dive into these ecosystems and you look at it, are they maintained? Is there someone there that keep pushing updates when they are needed? We know, for example, and that's partially proprietary, but like Log4j, the vulnerable to Log4Shell version of Log4j, are still something like 10% of downloads right now from Maven. That means that dependency updates is not done. So how much does this happen? That would be a metric. How fast is the uptake on this kind of stuff? And for less visible security problems too. That would be a start. There is a lot of way to slice that kind of data. One metrics would probably not be enough. You want to look at the diversity, but I think that's a good start. But also, like, go ask them. I think that's the thing we don't do enough. And that would probably, like, Rust worked because Graydon was fed up and pushed it. But also, like, do we see adoption? Rust got adopted en masse. Right? Like, if you look at it anyway, like, especially from a system library stuff, right? This is not a space that adopts new tooling fast. Like, you will literally have to have talk telling people to use address sanitizer still in 2026. Rust got adopted really fast on the lot, and people that use it a bit start pushing for it everywhere. That's a visibility that you hit a hotspot. I know it's not perfect. I can't offer you perfect metrics here because I'm more trying to push the model so people think about it and think about this kind of stuff, and even try to tell me I'm wrong, because I would sleep better at night if I was wrong on the rest. But yeah.
Thank you. Well, unfortunately, we don't have time for more questions, but yeah, you are going to have Thomas at the venue, so you can take your time. We have the lunch break now, so thank you very much again. So we have 1 hour, 15 minutes of lunch break. Whoever is watching from home, see you in a bit of time. And whoever is in the venue, we can all go together to the cafeteria that we had lunch yesterday. I think you all know where it is now, but yeah, we can move as a group, which is more fun.
This is working now? Okay. Okay, welcome back everyone from the lunch break. Now we have a talk on passwordless authentication in GDM by Joanne. Over to you.
So, hello. In this talk, I'll share the work that we've done to enable passwordless authentication in GDM. So, my name is Joan. I work at Red Hat. I'm a software engineer, and I'm one of the maintainers in GDM, and I'll also contribute to GNOME Remote Desktop and related areas. You can find me at joantolo@redhat.com, and my GitLab account is joantolo. The agenda of this talk, we will begin explaining what is passwordless authentication, then how GDM does authentication, the current limitations that GDM has, the solution that we've tried to implement to improve, reduce the limitations, and we'll finalize with a conclusion. Passwordless authentication. What is authenticating passwordless? Well, surprise, without using a password. This is usually done when you do multi-factor authentication, when you authenticate with multiple mechanisms, like using a passkey or face recognition, and also it's used in single sign-on. This strengthens the security by relying in public cryptography keys rather than in the human brain, which reduces the risks and threats and improves the user experience. In FreeIPA and SSSD, there are currently some passwordless authentication mechanisms available, such as passkey, aka FIDO2 token, smart card, and also external identity providers through the OAuth 2 protocol. GDM authentication. What is GDM? GDM is the GNOME Display Manager and is the program in charge of doing a graphical authentication and starting a graphical user session. Usually, when you use GDM, you will do a password authentication, as you can see here. But it can also do a smart card authentication. If you enable the smart card authentication in GDM settings and map a smart card certificate with a user, you will see these certificate lists and insert the PIN and authenticate. And also, GDM supports fingerprint authentication. The same thing, you enable fingerprint authentication in GDM settings and enroll a fingerprint with a user, and then you will see this text here that says, place your finger on the reader, and then you will be able to authenticate. Now, for those who are wondering how does GDM authenticate, now it's going to be explained. What you see here is GNOME Shell. The GNOME Shell is the window manager, and Wayland Compositor is the program in charge of rendering the icons and texts on the display. And this is a special GNOME Shell. It's running in greeter mode to allow authenticating, and it's running as an unprivileged user called GDM greeter user. So to authenticate, we need some privileges that GDM greeter user doesn't have. So how does the authentication? Well, communicating with GDM. So GDM, for each GNOME shell, is going to create two private DBAS servers. One is going to be used between GDM and GNOME shell, and the other one between the process that is doing the PAM conversation and GDM. Now, moving on the GNOME shell side. So there's this private DBAS server, and GDM is exposing a DBAS object, exposing an interface called user verifier, which will be used by GNOME shell. Usually, in the GNOME shell side, when you start password authentication, the GNOME shell will call the method begin verification, passing the PAM service GDM password, because it's doing password authentication. If it was going to do smart card authentication, it would pass GDM smart card PAM service. Then GDM will send some signals like secret info query, which makes GNOME shell ask for a password, and also could send info signal to display some extra text on the screen. And then the user would insert the password, then GNOME shell will call the method answer query with this password, and then the authentication. If it succeeds, GDM will send verification complete signal, and the new user session will be started. Great. Now let's move on the other side, the PAM conversation. So to do a PAM conversation, GDM for each PAM service is going to spawn a process called GDM session worker. So the private debug server is going to be shared between this session worker and GDM. So there's this private debug server, and in this case, the session worker is exposing a worker interface, and GDM is exposing a worker manager interface. And each one is going to use the other one to share the information. Usually, for a PAM conversation, you have different stages, and GDM iterates through these different interfaces, calling the initialize, authenticate, authorize, establish credentials, and open, the different PAM stages. At the same time, the session worker is setting up the PAM conversation. It's setting a handler to receive PAM messages. So the session worker could receive PAM message of type PAM text info, which is translated in the session worker calling info method. And at the same time, GDM forwards this info method to GNOME shell. Or it could receive the PAM prompt echo off, which is the one that is asking for the password. The session worker translates that into calling the secret info query, and GDM forwards that to the GNOME shell. Then, on the GNOME shell side, the user will insert the password that will be received by GDM, and the password will be returned in this secret info query return, and then the authentication will succeed or fail. Good. So everything works, it's fine, but there are some limitations. The PAM conversation is a bit rigid because the communication is blind. It treats all messages as text. And that is not very good for if we want to support some other special methods like passkey or external identity providers where we might require special messages like touch the device or show a web view. In some setups that you require, like in big organizations, they usually provide some multiple authentication methods, like, for instance, authenticating through passkey or using a smart card. And in the current design in GDM, you are not allowed to choose between different methods on real time. You only get prompt with one, and that's it. There's also some UX, like the UX could be improved. Like in the smart card certificates, the information doesn't fit properly in the buttons. And the last thing, we cannot support zero trust architecture if we don't support some extra methods that require to extend the UI. So we tried to improve the situation. The first thing that was done was defining a new PAM extension. And there's a special PAM message of type PAM binary prompt, which is just a stream of bytes. So if the PAM module and the GDM receiver agree on a specific format, then you have what in GDM is called the extension messages. In this case, we've created an extension called custom JSON, which just allows to send and receive JSON messages. So going back to the communication that we were having with GDM and the session worker, now the session worker can receive the PAM type PAM binary prompt, and it will parse this message. And it will detect, oh, this is an extension message of custom JSON type. And then the session worker will call the new method called custom JSON request that is sending this JSON message. GDM will forward this to GNOME shell, which also supports JSON messages now. The user will select the authentication method, insert the password or whatever is required, and then reply with another JSON message that will be returned in this method, and the authentication will go on. This new extension is supported by SSSD and AuthD. We have two new PAM services for that, the GDM switchable auth and GDM AuthD. And now, if we use the SSSD backend, the format of the JSON message is as you see here. So now, with one single PAM service, you start the conversation, and you will receive a JSON message that provides the current available mechanisms for a user. For instance, you can receive here a list of a password mechanism and also smart card mechanism and some extra information like the certificates for the smart card. And then the user, once does the authentication and everything, will return the selected authentication mechanism and the answer, like it might be the password or the PIN or whatever. And well, this is great because in the past, for different mechanisms, we needed different PAM services, and we had to have like different PAM conversations. And now, with one single PAM service, we are supporting multiple mechanisms at the same time. And this is a great improvement. And this results in some UI changes. Now, as you can see here, we can select between the different available authentication mechanisms, and also we still can select the available session types. The smart card UI has been improved, as I was mentioning before. So now the certificates are like look better, and you can see better like the organization information of the certificate with the icon that it's on the right corner. And then we've added support for the new passkey mechanism. This is a mechanism, is a two-step authentication. The first, you are asked for the PIN of the passkey, and then you are asked to touch the security key. And we've added also support for the web login mechanism. In this case, this is authenticating using the external identity provider. And you have to access to an external site and authenticate there. Here we provide a QR code so you can access there. In the future, we would like to also add an embedded web view inside the login screen. And the last change, now in the lock screen, you will see in the corner a small icon informing when the fingerprint reader is active, when the fingerprint authentication is available for this user. Yes, and now I'm going to show you a demo of authenticating with the new methods. The first method is passkey. Oh. Even with a video, the demo sometimes. Let me try to. Or download it, yeah, maybe, but I won't download it now. Okay, now it works. So there's the passkey user that has enabled passkey authentication, and you insert the PIN, and then you are requested to touch the security key. You touch it, and then you have authenticated, if the PIN was the right one. And also the external identity provider. In this case, we are using GitHub as the external identity provider. So you get the QR code, and I just accessed through the link in my browser. I inserted the code that is displayed in the login screen. And then I just have to authenticate in GitHub, and that should be it. And I just have to press the done button in the login screen and authenticate it. Conclusions. So this new feature has been included since SSSD 2.12.0 version. And for GNOME, we have the intention of having this available for the 51 release. There's just one last merge request in the GNOME shell. It's like the main merge request. And if we are inspired and motivated, we might merge it in this conference. Future enhancements, what we would like to do in the future. As I was mentioning, to be able to have an embedded web view in the login screen. Also, we would like to improve the PAM communication using a file descriptor to send and receive JSON messages instead of relying in the PAM architecture. And also, now that we've dropped Xorg support, we would like to move some GDM bits into systemd so other elements in the stack can adopt it, like starting and stopping graphical user sessions or and doing the authentication. There's currently a live discussion to decide how it will be the authentication protocol that would be used by other elements in the stack, like GDM, KDE, SSSD, or Polkit. Some reference links. We have 2 blogs. The first one is more to explain more into details how has been the interface using JSON messages. And the second one is explaining how the PAM communication has been improved. I think Iker is the author of both. And credits to Iker Pedrosa and Ray Strode. Those are the ones that started this project, and then Ray Strode started to work in a different area, and I took over and tried to get it to the finish line. And also to Marco Treviño, who's been working since the beginning, helping a lot in all the required areas. So thank you a lot to all of you. And that's it. Thank you very much.
Okay, we have questions.
Hi, thanks for the presentation. Can you show an example of how you would configure which authentication methods are required or can be used?
For configuring the authentication methods, in GDM, it relies on dconf, and usually, GDM has a dconf path called GDM login screen or something. It's GDM settings, or no. It's login screen. Yeah. Org GNOME login screen. So you would go to etc/dconf, and there you add the setting in the org GNOME login screen, and you would find there the enable passkey auth, or enable password auth, or enable smartcard auth, and that's how you, if it's then available for the user, you might get it on the login screen.
Okay, can you hear me? So thank you for the presentation. This is pretty cool. My question is a bit related to the one from the previous person. I'm interested in how this works at the configuration level, because typically in PAM, you have a configuration file for a service, and you have a list of modules, and they are tried in sequential order. So if you want to add the possibility to let the user choose which method to use, how does that work exactly? Like, does it need changes in PAM itself or in the PAM configuration? How would the PAM configuration look like?
You're asking how to let the user choose?
If I understood it from the video one video that you showed earlier, there was like a wheel, the setting wheel, where you could choose what authentication method you want to use.
Yeah.
If you have several ones.
Yeah.
How does that work at the PAM level? Because PAM is very limited in the sense that you only have a list of modules that are tried in sequential order.
Like they try to bypass the PAM limitations, so is the PAM module, in this case is PAM SSSD, the one that has like support for the different authentication mechanisms. And then in this PAM module, it's PAM underline SSSD.so. That's the one that is sending the JSON message and is the one that is sending the different supported authentication methods. So you don't have to like specify anything in the PAM module. It's all in the authentication backend and to display it or not in GDM settings as well.
Okay, so at the PAM level, PAM SSSD takes care of that and takes care of then showing, talking to GDM and showing what are the available methods, etc. And is this PAM SSSD tied to GDM, or is it generic enough that it should work in any?
You see, you said the PAM SSD is tied to GDM?
Yeah, is it specific to GNOME or is it generic and it should work in any?
Currently, it's supported only by GDM login screen, but I guess if other login screen like the KDE Plasma added support for JSON messages, it could use it. Like GDM is not, I'm sorry, SSSD is not like, it worked. It started working as first implementation for GDM, but it could work as well for Plasma login.
Okay, thank you.
Okay, do we have time for like one more question? If anyone.
So now with those multiple authentication methods that are available, I'm just trying to think in my head, which one of those would be available if you were doing the GNOME remote desktop login, and how would those be limited if they were not supported?
Yeah, that's a good question. It would be like it would work the same way when you use the external identity provider, because you would just get the QR code the same way. But for instance, when you want to do a smart card authentication, in this case you are connecting remotely, so you wouldn't be, like when you connect remotely, you would be able to use the smart cards that are connected to the remote system, not the ones that are on your remote client. But I've worked this last year in adding also support for using the smart cards through the remote client. For passkey, I think it's not supported like remotely. Yeah, you would be able to access to the smart card that is connected locally, but in this case, because you are remotely, you won't be able to touch the passkey device, so it wouldn't work. Yeah.
This is great work, by the way. This is cool.
Thank you, Scott.
Thank you very much for the presentation.
Thank you.
I think we don't have any more time for questions for this talk, but yeah, thank you.
Thank you.
So the next presenter is Carlos. I don't know if anyone... Oh, hi.
Yes, all good.
We can give it a try and see if everything works well for him. And we can start right away, whenever you're ready. Oh, sorry. Sorry, quick announcement. I was about to forget. Sorry, I need your attention just for 1 second. First of all, at the reception, at the check-in desk, there is a paper with lightning talks. If you'd like to do a lightning talk, you can just add one. And the most important thing is that I have the lunch tickets for tomorrow. So if you'd like to have lunch tomorrow and you have paid for it, you can come and get the tickets, like to me, find me either here or at the reception. I'll be in these two places. Or you can just pay for the lunch. We have a few extra tickets, but very few, so yeah. Just let us know. Tomorrow is going to be everything closed around the venue, so yeah. Just letting you know that it's the best option to kind of get the lunch. It's going to be the same cafeteria that prepares the lunch for us in advance. So yeah, we are going to proceed with our next presenter, Carlos Garnacho, and he's going to talk about using Matter as an application test framework.
Hi everyone, thanks Anissa. Yeah, so this is, well, I would have wished to have it more prepared, but yeah, I've got some material which is work in progress and whatnot, but yeah, I'm going to talk about a little bit about application testing. So the basic premise is that, yeah, everyone likes work that works nice and works as intended and doesn't crash and everything. But the thing about it is that, well, writing good code and code that survives all situations and writing resilient code is not an easy task. So, I mean, there has to be some, well, it's not something that will come by itself, so you need to do something for it. And there's, for example, validation techniques that do help with ensuring that your code doesn't follow anti-patterns or does the thing as it is expected by the GLIF libraries and whatnot, but yeah. And then there is also, well, static analysis tools like Clang Analyzer and Copperity if you want to go to privative solutions, and I'm sure of a few others. But the thing is that validation only gets you so far. There is a fair amount of false positives and also false negatives, like things that the static analysis will miss and it is actually bug, or things that static analysis will tell you it is buggy, but it is really not. And same with validation and linting and everything. It could catch many situations, but not all of them. So you need something in addition to this. It's not something that you can run a script on and get everything that might fail back to you. So that's why I'm more into actual tests and writing actual tests for the application, like actual code that runs through everything. And the most usual techniques for this would be unit tests, like trying to get a piece of functionality and trying to test it thoroughly. And then there's functional tests which are like a higher level. Yeah, they basically pick the application or the service or whatever you want to test more as in a real-life situation, and tries to test it on the outside and tries to make it behave, the tests behave as if it was a real situation. So the objectives would be evidently to maximize the code that is executed by the test suite, because yeah, that means that you are actually testing the code and actually testing that ideally, you should be testing that it works correctly by searching for certain behavior and whatnot. But actually running the code in the test suite, it should be something to aim for, basically. It also helps you, once you've got a proper enough test suite, you might have a way to identify regressions quickly and actually protect that your branch is going to work well and spotting things before you merge them and whatnot. And to some extent, once you are really far into the testing coverage, you can actually identify unused ordered code, like things that you thought were covered in some situation, but you get to realize that they are actually there for no reason currently. So you can actually get to notice this unused code and remove it, which also leads to increased test coverage. So it's a win-win. For measuring this, you have the multiple tools. You usually compile with coverage support, and then you have several tools that are able to extract this information and to show you the code with some hints to show you which code is actually run by the test suite, which code is not, and whatnot. And there are 3 different flavors of test coverage, which usually these tools provide all at the same time, which could be the percentage of functions called, which is relatively easy to satisfy, as in, it only, as soon as you call a function, it will be given as good, so you've called it and validated somehow a little bit of its behavior. Then the next one in level of complexity will be the lines execute, which means that inside those functions you would go into these paths and see how many lines, if you have an if-else, and you could check which of both paths are you testing, or both of them, ideally, and whatnot. And then these well, I call it paths, it might not be the best term, but it would be the conditions that you have inside ifs. For example, if an if has if this and that, or that and that, then there is a combinatorial explosion of combinations that you ideally should check for all of them, because testing both paths in an if and else, it allows you to validate the code inside of that, but it does not allow you to validate whether all the conditions in that combination actually do something else wrong down the line, maybe, and whatnot. So, but this is actually really hard to satisfy, because on every while, on every for, on every if, and all of these conditions that you might have to test for all of the possible combinations, which is actually insane. Coverage has a fairly strict definition of good. I think this is relatively common, like this gcover and lcov, and also the GitLab UI all agree on these percentages, like less than 75 testing percentage is considered bad, and it shows as red. More than 75, it starts to be fine, but it's not still great. More than 90, it's considered good, more usually, but then I realized that there's a different shade of green, and it drives me bonkers in the libraries that I support, that I maintain, because I'm and some of them around between 90 and 90% testing coverage. And I realized that GitLab has a darker green for the actual good state, and I've not reached that yet. And actually, the thing with this is that I don't know if you know the Pareto principle, like, for example, like 20% of the available thing, of something available takes 80% of the resources, and things like that. It can apply to plenty of things, and this is one. Like getting to a point where testing is fine, or, well, no, not fine per this definition that I wrote here, like needs improvement, it could probably take just about as much time as it takes to take it to the other 90 or 95%. Because, yeah, the corners that you have left to test, they get harder to reach, and then you have to write way more tests. You have to write way more specific tests, and then, yeah, the effort easily increases. So yeah, reaching to an actual fine or with coverage per these principles, it is quite a hard task even for libraries, which, I mean, library, I think, is a good sample for this kind of testing coverage and everything, because an API, a library API is basically already the code snippets, so you can call them and everything. So exercising the API is a way to get through most of things in a library. But in an application, yeah, there is additional challenges, definitely. And for these applications, yeah, the thing is that you have to test plenty of user interaction, like testing drag and drop of things, or testing input methods. If you implement something that you can type on and it's not a GTK entry, you should ideally test for internationalization and input methods and whatnot. And there's drag and drop, and there's people clicking, there's keyboard shortcuts, there's lots of user interaction driven through all kinds of devices that ideally you should be testing in applications. And but it is hard to automatize this for testing. So there must be something like I've been checking out of curiosity. I don't know if Control Center has coverage supporting CI. What is the percentage? 60. Yeah, that's what I expect more or less. I checked out of curiosity Nautilus, and it's also around 50, which is already pretty good for an application, but it shows that the unit tests only get you so far, because you have so much else to test other than the inner components that you can test individually. There should be ideally something that allows you to test something globally. And what would be ideally here, it's something that can run fully automated and headless, like something that you can plug on CI and have run on every merge request and test that nothing breaks and whatnot. It would ideally have these user interaction patterns thoroughly tested, and yeah, there's plenty of things plenty of corners that an application has, and it will be nice to test. And then to some extent maybe for individual widget testing and things like that, you could have ref tests. This might be less useful for if you redesign an application. You might have to redo all the ref test samples and update all the images, the reference images. So comparing images it still comes out as successful in CI. So this is ref tests are maybe more useful for testing individual widgets or things like that, which Nautilus and settings and whatnot they have by the ton. And the prior art, there used to be Dogtail back in the day, like way long back in the day, and it was pretty entrenched on older principles. Like it used accessibility to identify widgets. Like it's something that you can do still nowadays, but it is not the best tool for that, because accessibility has got enough with what is got to do in addition be a testing framework for applications. And it also used Xtest to simulate input, which might be the most canonical use for Xtest, because in other places it's used for a remote desktop and things like that that it was not meant for, but also Xtest, it only got used so far. Like you could simulate keyboard and pointers to some extent, but you couldn't do any complex input, like testing input methods or testing with another key map or testing. And it also used XBFB to run headlessly, and nowadays we are moving away from X11, so it could not be ideal to rely on legacy code to have your test framework running. And it ran externally to everything, to the app and the compositor, and it tried to modify it somehow, but it had quite a lot of limitations. But time went on. There's so much has changed since then, and now we have a different set of challenges. Like Wayland has made everything so much better, but except testing. So, but input testing is actually out of scope with Wayland protocols and whatnot. So it is more of a paradigm shift that we have to adapt to. But then we have to pick and integrate a compositor into CI. I think GTK is using Weston for the test suites. Yeah, I think so, yeah. And I don't know what others are doing. I think Nautilus was still using XWFB, which is the replacement, the spiritual successor of XBFB. But it's still X-Wayland, and it's still running X11, so it's not the best approach. I went back. And what a nice solution could look like. Ideally, I mean, we have our own platform, and we have our own environment, and we have our own compositor. So it would be nice that we could use Motor for these things, and have Motor be a dependency for the test suite in applications, and then running things headlessly over there. And it would be nice to run things in your own test suite, so you can assert for your application behavior, but after inducing changes in the compositor. Like I press a key in the compositor, I expect that my entry has emitted the change signal, so I can assert for that. For this, I started, it's more of a proof of concept still, but I started working on on the changes necessary for this combination of compositor and application inside a test suite. And I've been able to make Matter coexist in the same process as an application, as a GTK application, by, well, basically changing the default main context that Matter is running on. Matter has already a number of other threads with their own main contexts, like the KMS thread and the input thread and whatnot. So it kind of made sense that its main thread also has an identity, and that we can swap it for this use case, for example. And ideally, it would be nice to have something to wrap in this framework in a nice package. And yeah, I wrote a small proof of concept, and yeah, it requires this branch is still not merged, the Matter branch. I think it could be merged fairly soon, hopefully. But by GNOME 50, I guess it will be there. This proof of concept does require that branch to be able to run something, but it is able to actually run a GTK application with a compositor within the same process. So the nice thing is that it is also introspectable, so it's not C-specific. You can test if your application is written in Python. You could also kind of do Python tests and integrate this way. And yeah, this would be this is how things work currently in this proof of concept, like creating a kind of context that you start up before running GTK in it. So after that, the Wayland display is overridden, and you can run the application code within the compositor that has been created by this context. What is missing? Plenty still. Obviously, this is a proof of concept, but there is quite a number of things that they are already exercising in Matter's test suite already. It would be nice to have input injection for mouse, well, for every kind of device that you might want. We don't have that much in Matter, but it would be nice to have. That's on me, I guess. It would be nice to have a way to inject things from input methods, like being able to test that your application works correctly for Chinese or whatever. It would be nice to have an API to snapshot for reference images and for comparison for ref tests. It might be nice to have some scriptable input also, so that it's not like writing everything on code and like move mouse, assert that the mouse is on the widget, click mouse, assert that. It would be nice to have some more scriptability over there. And it would be also nice for certain user interaction patterns, like be able to replay EV, IMU, or live input recordings. So you can just ask for a recording and make a test case for something that was given by the user. So plenty missing. But once everything is in place and you have a good testing coverage, you can actually get quite a lot from it, because you can run ASAN to find leaks. And yeah, if you have a pretty good coverage, you could have a good chance to find many leaks and to find quite some misbehavior that you might miss. And now you have something to have the CI do it for you. And you can also run msan for memory corruption or tsan for threat, race conditions, and everything. So, but these tools kind of rely on, on having pretty good coverage already, because they expect, they run over the code you run in the test suite. So it's not like, unlike static analysis that looks at the code from far and tries to figure out things, this expects to run the code, basically. And it could also, this could also allow like other things to test, like we care quite more now about mobile, about now with LibRQuadec supporting mobile vertical layouts and whatnot. So we could test for that, and we could test for other kinds of form factors that might be there. And we could also look for other system integration, like running portals inside dbus run or something like that, dbus run session. So you could actually check that your application is integrating correctly with the system already in the test suite. That would be nice to have. And yeah, I don't have that much more material, so if you have any questions.
Thank you, Carlos. So yeah, we have 10 minutes for questions. Anyone watching from home, feel free to send the questions in the chat.
Yeah, this is actually interesting. I mean, something we are looking at, because I don't know if you've been seeing that at GNOME we're developing these tools called YARF, which is basically a driver for testing, which allows to do to control a backend. At the moment, they're just VMs or mirror, but I would actually like to do a Matter backend, which allows basically to write tests using Robot Framework, which is the Nokia framework for testing. And I think we are already using for doing complete tests. So you run on VMs and basically run things there. But it would be nice to be able to make Matter for Citizen there, so we can actually run tests to that. And I think it will help to have already a base for writing tests for GNOME, where you only have to care about doing the actual test scripts. I think it's not covered by CLA, from what I can say. You can help at the moment. I mean, there are no checks on CI on that, so I think.
For how long?
But anyways, I mean, it's a thing we could actually be integrated very well with this. I think we could have some part of the, all the management of the testing themselves too.
Yeah, no, sounds something worth considering. And I mean, this is not to diminish either, like, how is it called, this thing where you get the needles and you can compare these images.
No, we only use...
yeah. So I think that, I mean, that there might be different stages where you want to test and you might catch different things. Like all testing, the more testing you have, the better. It's never enough. So yeah, it's like these things can actually coexist together, and I don't think this would take over. Yeah. Yeah, no, but it makes sense. Yeah.
Hello. I'm up here.
Hi.
Yeah, I'm really happy to see more testing tools. I spent a while looking at OpenQA, as you know, which has good things and bad things. It's very heavyweight. It's probably the bad thing. It's very powerful. That's the good thing. But the main thing I learned is that what we really lack is a way to define these tests that's independent of any tool. because the dream would be if you could migrate from one tool to another, right? Like, if you have a set of screenshots, like reference screenshots, and you can click here and stuff, having a standard format for that would be really nice.
Definitely. Yeah, that's why I was trying to push for ref tests being used for individual widgets and things like that, because it becomes easier to test a single thing than the whole application. And if you redesign or the CSS changes slightly, or there's a different pixel in the shadow, that's basically worthless to test or to spend too much time on. So
yeah. What do you think about fuzzy image matching as a feature?
Yeah, that might be a possible way, but then you get into false positives and false negatives, and yeah, it's got pros and cons, I guess.
Yeah. Okay, thanks.
Any other questions in the room? Okay, I think that's it. So some people are writing in the chat, great talk. Carlos, thanks. And yeah, thank you so much.
Thank you.
Oh, sorry, we have a question just arrived, if you wouldn't mind answering.
Sure.
Anyways,
Sure.
we have some more time for your talk. And yeah, maybe I missed this. Would it be possible to inspect, grab visual output of the tool?
Like a demo or something?
So this is the question.
Oh yeah, but yeah, that would be the idea behind ref tests, like the grabbing an image or grabbing something from the application, grabbing in order to compare it is what ref tests are about. So I guess that would be the question.
Yeah, I assume, I hope so. If not, I'll just ask you to take a look at
if not,
track one.
I will look to reply more properly.
Thank you so much. If there are no other questions from the public, yeah, I think that's it.
Thank you.
So we have, let's say, 25-minute break now, a coffee break. Kind reminder, if you'd like to do a lightning talk, there are the posters at the entrance, at the check-in. And the most important thing, I have the lunch tickets for tomorrow. If you have paid, come and get your ticket. If you haven't paid and you'd like to get a ticket, anyways, come to us and we'll figure it out. Thank you. And hello everyone, and welcome back. I hope the coffee was good, the snacks were nice. Whoever is watching from home, we are going to start the next session. We are going to let the stage to Adrian Vovk, and he's going to talk about session Save Restore.
Hi everyone, I'm Adrian, and I'm going to be talking about session Save Restore. This is what I've been working on for quite a long time. So I'd like to walk you through what it is, what progress has been made, what's left to do, so on. So let's start with what it is. What is this feature? So the idea is pretty simple, actually. You go into the Settings app and you turn on that switch, and then at some point later, you're using your system, you have a couple apps open, you're doing something, and then for whatever reason, you need a reboot or log out or something. So your system goes away, the computer shuts down, everything should be gone. But then the next time you log in, your system's back to where it was, and you can quickly resume your work. All the apps are back, they're positioned the same. The content in the apps is back to where it was. So why do we want this feature? Well, it's a very commonly requested feature. Also at Red Hat, we have customers asking for this, but it was one of the kind of deficiencies that people like to point out about Wayland, that apps are not restoring their position on screen when you launch them, things like that. But also there are a few very practical benefits, like surviving crashes, not just of the app, but of the session, or even of the entire operating system. So if your kernel panics, generally you lose everything you were doing, but with session Save Restore, it is possible to actually then restore a snapshot taken, like, let's say, within the last 15 seconds, and then you can very quickly get back to what you were doing. For me, one of the more interesting benefits here is encouraging updates. So for robust updates, you really want to reboot your system because, well, that's the more reliable way to do it. And if you have an immutable system, then you actually must reboot the system to apply that update. However, rebooting the system is quite disruptive. You lose everything you were working on, and for some people, like me, for example, I will have all my windows open and set up, and I'll work like that for a week or 2 weeks, but that means I'm not applying updates for a week or 2 weeks. So ideally, we should reduce the burden of installing updates so that people do that more. And the groundwork we lay here could be used for other fancier features. For instance, power management. Like mobile phones, what they will do is they will actually completely shut down your app to save either RAM or battery or whatever. And another thing is cross-device window handover. So like, I think Apple calls this handover, where you have a window on one device and you can, if the app supports this, ask it to serialize its state, send it over to a different machine and restore there. And then, now I'm not saying that these are features we're actually going to be working on, but it sets the groundwork. It actually makes it possible even in theory. Did that just skip to the end? Okay. LibreOffice, what are you doing? Okay. So how does all this work? And we could start with some of the history, and that's the X11 Session Manager Protocol. And it's quite simple. Apps register with the Session Manager, and in GNOME's case, this was GNOME Session. And the Session Manager keeps track of which apps were registered, and then on the next login, it just restarts all the apps. And the apps do all the saving and restoring themselves. And actually, they were quite forward-looking here. It's not using X11 as its IPC. It's actually using some bespoke IPC format. So theoretically, we could have used this with Wayland. But it has some problems. the kind of big one is that it's all command line driven. So when I said that an app registers with the session manager, I meant that the app gives the session manager a command to run at next login. And usually you would like serialize your state into a file and then put the file name and some command line flag and give that to the session manager to be restarted later. Of course, that means that none of this works with a sandbox. I mean, we don't want sandboxed apps to be able to tell the operating system to run some commands at login. It's also been broken in GNOME for quite a few years, and since we ported to systemd services to start up the actual GNOME session, it just hasn't worked. And so we dropped all of this code along with all the big GNOME session refactors and the X11 removal that happened a few releases ago. So if we want this to work with sandboxing, the replacement would be a portal, of course. And XSMP isn't really fundamentally that broken, so we're actually not diverging too far from it. Apps still register, the session manager still keeps track of what needs to be restarted on the next login. But instead of doing commands, we keep track of the app ID, and we relaunch it by relaunching the desktop file. So we just essentially just restart the app the way you would start an app in any other case. And then the app, on the next startup, it will re-register again because it is now running. And when it does that, the session manager will give it a, quote, restore reason. Now, the restore reason tells it what to do. So it'll tell the app, hey, this is just a normal launch. You should restore maybe your window position, but not the contents inside of the window. Or it can say you're doing a full session restore as much as you can. Or it could say that you're doing, you just crashed. So maybe restore some things, but be careful to not get yourself into a crash loop. And I'm glossing over lots of complexity. There's like tracking for multi-instance apps and all that that's relevant for other desktops, but isn't really a thing in GNOME. Wayland. So X11 with the XSMP, the app would save everything itself, including all the window management state, because on X11 an app could do that. So it would just save its position, and it would ask the X server for its position and size and all the window management flags it felt like asking about, and then it would write them down and then later restore them. Okay, there we go. But on Wayland, apps can't position themselves for lots of reasons. So instead, with Wayland, we have this XDG session management v1 protocol where the app doesn't do any of the window management saving. It asks the compositor, hey, can you save my state and give me a token, just a big random number essentially. And then the compositor saves everything, and then later the app gives that big random number back to the compositor, and the compositor will say, will restore whatever makes sense to restore in this context. And this is better than what we had with X11, I'd say. First, it's more consistent because there's one centralized place that decides what gets saved and what gets restored. But also, the compositor can execute some kind of policy that makes sense for the desktop. For instance, like we give the restore reason to the compositor here as well. So on a normal app launch, the app might restore its position, but we don't want to restore the workspace that the app was on previously because we're just launching the app normally. And it would be really weird if you were on the third workspace and you launched the app and it opens on the first workspace because that's where it was last time. With the old X11 way of doing things, the app would have to think of that edge case and would have to be aware of workspaces, which it might not have been, and different desktops do things differently, and then, you know, this becomes this whole mess. With the Wayland protocol, the compositor decides that during normal launches on this desktop environment, it doesn't make sense to restore workspaces, so it doesn't do that. Now let's get into the hardest part of all this, and that would be GTK. Because one thing that we were really missing with XSMP is this nice high-level API for apps to interact with session save restore And so it wasn't that popularly implemented by apps. And I believe that if we want apps to support this, we need to give them an easy way of hooking into this system, or at least as easy as we can make it. So the overall approach with what I want to put into GTK is, well, first, GTK application drives it all. It talks to the portal, it handles the Wayland protocol, and so on. So it's kind of built in that way. And it would be built around what I've been calling state snapshots. So the idea is that the app is running, it's in some state at any given moment in time, and then at that moment in time, GTK can decide, hey, I want to collect all the state, like snapshot the app as it is right now, serialize that, write it to disk somewhere to be later restored. We handle this per window, so GTK is natively aware of the different windows, and it actually, like we could have done this in such a way where we just, in the GTK application, we have some signal to collect and restore, and then the app would have to loop over all of its own windows and do that. But we made GTK application aware of this because it actually fixes quite a few edge cases that I'll get into. Restoration before activation is quite important. So restoring an app has quite a few life cycle implications. Like, for instance, if you have an app that was previously saved and then it's not running at the moment for whatever reason, and then you open Nautilus and double-click a file to launch that app, what does the app do? Does it restore first? Does it open a new window to handle that file? It's not really clear. However, there is a case where we already handle this, and that is if an app was already running and the user was already doing something in it, maybe they have a couple windows open already, and they launch the app, and the app needs to decide what to do with that activation request anyway. So my thinking here is that restoration isn't really that different from an app that's been running for a while and the user's already done some things in there. So what GTK will do is when you launch the app, it will restore the app first. And that will bring the app up to the state where conceptually it's the same state as if the user has been using the app for a while, has a couple windows open, and so on. And then we give the app the activation request. And that means that all the edge cases of save restore lifecycle kind of go away because we pretend that that case is the same as the case of an app already running. We have a periodic autosave feature, and the reason for this is that crash resilience I mentioned earlier. We want the apps to be able to, like when they're active and focused, I think it's every 15 seconds is what the code does, but it's customizable per app. GTK will serialize the app state. It'll take a snapshot and save it so that if the app crashes or the session crashes or the kernel crashes, you lose at most 15 seconds of what you were doing in your last focused app. And the overarching goal here is that GTK hides all the complexity. That's including the Wayland protocol, and that's including a bunch of these edge cases. And I'd like to walk through one of these edge cases just to kind of demonstrate why this is so difficult. So here's an example edge case. The user is running an app. It's a multi-window app. So when they close like the second or third or fourth window, we don't actually want to ever restore those again. Because during a normal launch, we only launch the one window, and the app is that window when you close it, and the app keeps running, and the user is done with those windows. There's nothing to restore there. But then they close the last window of the app, and this one we do actually want to save because on the next launch of the app, we want to restore some things from there, like the size and position on screen. So GTK dutifully collects the state of this window to save. And then let's say that for whatever reason the app doesn't immediately exit Like the last window is gone, but maybe the app is being held running by a search provider, or it's running some task in the background, whatever. The app keeps running. And then the user changes their mind before the app quits. They open their app grid and they relaunch the app. The app never quit, so it gets reactivated. But this is, from the user's perspective, like we relaunched the app, they're being shown the first window again. So actually, GTK needs to restore that window, but it needs to not restore the rest of the app. It needs to run part of its restoration machinery because the app was already running. So parts of the app that remained instantiated shouldn't be restored because they're still alive. But this new window should be restored. So this is an example of one of those edge cases where GTK needs to be aware of windows and needs to be very careful about when it collects state and so on. And actually, from a code perspective, this is even more complicated because GTK isn't writing this last window to disk necessarily. It actually needs to serialize it and keep it in memory to use it later. So yeah, there's lots of edge cases like this to handle. So given that overview, we have the first API that made it into GTK. And this one was quite simple. We have signals to collect state into a G-variant dictionary, and that is our method of serializing the state. And then we have signals to restore the state from the variant into the app. And these signals were on GTK application and GTK application window. So those two classes were special. They got special treatment by GTK application. They're a special case. And this entire API is completely synchronous. So we just emit the signal, and when all the signal handlers return, we assume we're done. We assume all the state has been collected. That's it. And this API got actually pretty close to landing in GNOME 50, or that's GTK 4.22. We almost released this. It also has a GNOME Builder integration, which these restore reasons I mentioned earlier, the portal will give you the correct restore reason. But if you're testing your app, you actually want to be able to spoof those to check that your app behaves correctly under all those different circumstances. So in GNOME Builder, and this is already there today, though it doesn't do much because this all hasn't landed yet. Next to the run button, you can drop down in there, and there's an option to emulate a restore reason. The first API had a couple of drawbacks. So first, it was entirely code-driven. So if you're an app developer and you want to collect some state from a bunch of G objects, and your state is in properties, for instance, you're going to be writing quite a bit of code that's like GObject get the property out of the object, and then you store it into the variant, and it's just a lot of repetitive kind of code. The other issue is that because these signals only exist on like kind of the top level of the app's hierarchy, and that's the window and the application itself, the state there is kind of flat. So you're given one variant to serialize into at the top level of your app, and that's it. But apps aren't actually flat like this. They have navigational hierarchies. Like the settings app has a bunch of subpages in them, and each subpage may want to save and restore different state than any other subpage. But this API wasn't particularly well suited for that kind of nesting. There was no helper for building up a tree of state that you would want to then kind of pass down your navigation hierarchy. Because we had special classes, there was no extensibility, so there was no kind of defined way to take some random data type that you have that you may want to save and restore and mark it as this can be saved and restored, give it into the system, and then let the system take care of it. There was none of that. So you would have to, yeah, this was just missing. It also lacked bulk data support. So what's bulk data? For some apps, like I'll give an example of GNOME text editor, you may have like all the Windows state you want to restore, but then you also have this unfinished text document in there that may be many megabytes in size. And we don't actually want to serialize that text document into this save restore system, because then we're copying the data into memory, and we're then writing it all to disk, and it's so much unnecessary work, basically. And the file might be quite large. We don't want to do it like this. So instead, what we want to do is we want to save that to a file somewhere off to the side, and then save the file name in the G variant, so that we don't have to have any special code paths about copying the content into the save restore state. And ideally, this keeps the save restore, the state snapshot small, so that this whole system's kind of quick and it's not going to bog the system down too much. And on other platforms, they also have this restriction, and some actually go further. Like Android has a hard cap of, I think, 1 megabyte. Like if your state ends up being more than 1 megabyte, it just will not accept it. And then the biggest drawback is that apps want to do asynchronous things. And for example, back to this GNOME text editor example, when you save the text document to disk, that's an asynchronous operation. It may be a very large file, the disk may be slow. We don't want to hang the app while we serialize everything. So we want this to be async. However, the API is fully sync, so you can't do that. And this async problem is kind of what ended up killing the first API. So I was thinking originally that there was some way to kind of retrofit async into this API and just let it be. But it comes with a big pile of race conditions that we couldn't fix. With like if that API had landed, we would be stuck with a bunch of race conditions that would make it not feasible. Like the obvious example would be that if an app is being shut down because the session is ending, the app will try to serialize its state, and that's asynchronous. And before it's done, GTK is not keeping track of the fact that the app is still doing something, and so GTK exits because it thinks there's nothing left to do. Meanwhile, the app hasn't finished saving its state, so then the next time you launch the app, the state's gone. Whoops. But there's another edge case, and so GTK application is a subclass of G application. And that means that when you're an app developer and you're connecting to like activate and open and command line, all those activation signals that tell you that a new instance of your app has been launched, those are the raw signals from glib. And there's no way to delay that signal emission. And so what this does is it breaks this edge case from before. And let's go back there. So this edge case, again, user closes the last window of the app, GTK saves the state, app doesn't exit, user relaunches the app. So what happens if GTK collects all the state to save is now asynchronous? Now we're doing a bunch of work. And rather than the user relaunching the app before the app exits, the user changes their mind and relaunches the app before the app is even done collecting its state. How do you fix that? I couldn't think of a way. I don't think it's fixable. So the decision was made that there's actually no way to retrofit async support into this API. And this issue came up because I actually published this API to app developers, and a few apps actually got ported. And one of the big pieces of feedback was, well, I want to do something async here, but I can't. And they would come asking me, well, how should I do this? And I'm like, well, you actually can't do that. So right in time for 4.22, I think like right before the RC or something, we pulled this API. We just hid it, basically. All the public API pieces got deleted, and all the plumbing is still inside of GTK, but it got hidden. And then immediately after the release, we reverted that and brought it back, because I was hoping that for GNOME 51, we would have a second API. So I wanted to kind of minimize the amount of change to the first API. So I thought, well, let's just invent async GObject signals. And it didn't end up being quite as hard as you'd imagine. The idea is it's just a signal where you give it this async signal context thingy. And if you want the signal emission to become async, you call defer. And for every call to defer, you call complete later. And it would also have some plumbing for returning values from your async signal handler. So you would call return. And this would be like gtask. So there would be return bool, return pointer, return error, and so on. And then the emit function for that signal would be asynchronous. And then all those return values would go through an accumulator. It's a glib signal, but asynchronous. And if you don't need asynchronous work, then you would just simply never defer that context, and now you have just a normal synchronous signal. And then we also went through and fixed a lot of the other limitations of the first API. So now there's an interface, GTK restorable, which you could implement in any object, which would give you these async signals and then would let you participate in the save restore system. And this would come with default implementations for common widgets. So like, for example, libadwaita's navigation view would delegate these down to all of the subpages inside of there. And then all widgets would actually implement this as a no-op, so that anywhere in your widget tree you can collect some state and then construct a state tree. And when I say state tree, yeah, so it was a flat bit of state, but now it is actually a tree. So we fixed that limitation. We added bindings. So the idea is that you can take a GTK restorable and bind it into another one under some name, or you could bind a GObject property into some name inside of a GTK restorable. And so the idea is that that's a more declarable way to collect your state. And then we integrate it with GTK Builder so that you could do this completely declaratively in your just UI definition file. And it came with a solution for bulk data as well. But the second API was overwhelmingly rejected by the maintainers of GTK, by the libadwaita maintainers. And the bit of feedback I got was that async signals is not something people are interested in, which, fair enough. So now, the last couple of weeks, I've been working on a third API proposal, which is not too different from the second API proposal. Like, we keep most of those benefits of the state tree and bindings and all that. But we came up with a slightly different way of doing it. So there's no more async signals. GTK restorable now has async methods or vfuncs. And now, since it's just an interface and there's no weird machinery for, like the bindings in the second API relied on connecting to the signals. Since there's no more signals, we can't do bindings this way anymore. So instead, now we have this GTK state node object. It's a class, which is itself is a restorable, but now it has bindings. So the idea is you have a tree of these state nodes or simple restorables, and you can kind of plug it together and assemble your state tree that way instead. And the big feature here to make this nicely usable is delegation. So you can implement a GTK restorable on your class, but internally you can have a GTK state node, and if you want to implement GTK restorable for yourself, you could just delegate the implementation to the GTK state node. So this way, we kind of get the benefits of the second API without using async signals. Now, yeah. So when's all this landing? So the Wayland bits are mostly there. The protocol has been released. It's a staging protocol, which means it's ready for use by toolkits and compositors and all that. The Mutter side of this landed in 51.beta. However, I know that there are some bugs to iron out when you actually put this together in a full session save restore. There's some jank. And the GTK parts, the Wayland parts for GTK were released in GNOME 51 alpha, but it's not usable by apps yet. Then the portal, so the front end, which in portals this is backwards, the front end is the API that apps talk to. So the portal front end is, it's not quite done yet. The KDE people have, I've talked to them, they've okayed the kind of core concepts of the portal. Same with some Firefox developers that I talked to. It's one of their more complicated apps that I wanted to make sure that it's suitable for them. But the details still need work, like the specific restore reasons and some of the language in there. So that's a pull request that you can look at to keep track of this work. Now the GNOME backend, there's a private API inside a GNOME session that landed in GNOME 50. And then I have a conversion of that API into an actual proper portal backend that's waiting in a merge request, that's waiting for the front end bits to land. And the KDE people, I know they're also working on a backend, but they would also be waiting for me to land the front end work, so they're waiting for me to get this part done. And then the GTK parts, so the third API's basics are in a branch, and right before GUADEC, I pinged all the GTK maintainers and basically asked them for some feedback, which I'm sure I will be getting at some point within the next few weeks. So it's not, I'm not sure what the reaction is yet, basically. But also the first API is still in GTK, and it's still exposed. I haven't plumbed all these basics into the actual, into G application and all of its handling of the portal and of Wayland and so on. So the first API, which is still exposed, will probably be hidden again in time for GNOME 51 so that we don't release it and don't accidentally stabilize it. And ultimately for the GTK bits, I would really like to have some apps ported to this before we make it stable in GTK, because it's such a big and complicated API that we really need to be aware of what the ergonomics look like before using it, before stabilizing it. So ultimately, we're not making it in time for GNOME 51 for session save restore, unfortunately. But that's kind of the status. So if you have feedback over this API, if you're an app developer and have ideas, please message me on Matrix or talk to me in the hallway. So thank you all for your time and your listening, and happy to take questions.
In the past 7 years, I developed and maintained a shell extension with the future exactly same as what you presented today, and over the years, over the years, I also saw some extensions with the similar feature, but in a different way. in the official extension website. So after this feature roll out in the future GNOME version, what does it mean to those extension? Will you provide some APIs for extension? And will you provide a switch so that in the extension this feature can be shut down, and then extension take over this feature?
I'm sorry, that wasn't the easiest to hear. Are you saying that one of the questions was if there's an option to turn this off? Yes, there is. There's a user-facing option in the settings app, and there's a API-facing option if your app doesn't, like your app has to opt into supporting this. But I'm sorry, I didn't really get the rest of your question. Could you repeat that, please? Yeah, it was a little quiet, sorry.
My first quick question is because there are some extensions to do this stuff, to do this feature, like mine extension already do save and restore sessions. So if after this feature officially roll out in the future GNOME desktop, what does this mean to those extensions?
Oh, about shell extensions. Oh, so what does this mean for shell extensions?
Yes, shell extensions, sorry, GNOME shell extensions.
I suppose that shell extensions could probably, I mean, I might not be the most informed about shell extensions. My impression is that many of them are kind of stateless. Like a lot of them are either do some cosmetic change to the shell, which they don't really have any state to save or restore there. A lot of them are status indicators of some kind, either in the quick settings panel or something like that, or they'll show your tail scale connection status or something. And those you can just query the underlying service or the underlying setting. As for if there are stateful shell extensions, I don't see why they wouldn't be able to, well, they wouldn't be able to talk to the portal. But they are inside of GNOME Shell, and GNOME Shell is involved in save restore through Wayland. So GNOME Shell is kind of always saving and restoring its state in a way. Like it doesn't talk to the portal, it just always assumes that it needs to save and restore state because it's driven by the Wayland clients asking to restore Windows state as needed. Yeah, I don't know. I would have to think about, if you could give me examples of, message me on Matrix or something, of examples of stateful shell extensions, I'll give it a think.
Maybe I will send mine shell extension links to the, in the Matrix room, you mean?
Sorry? Yeah.
Okay. As a second question is, will you provide shell API for the extension for, yes. So
okay, yeah. So shell API, I would have to see what, I would have to think about it. I would have to see what shell extensions need, and then from there we can see. Because it does complicate things. The shell cannot talk to the portal.
Yeah, I think it will be useful because in shell extension we can do anything to modify anything to add any useful, intuitive, fancy features. I think that would be useful.
Mm-hmm.
Okay. Thank you.
Thank you.
Any other questions? So we can take one more question, otherwise, actually, we are running out of time.
Since models are defined on the GIO layer, and some people might have some state stored on there, not basically in GTK, wouldn't it perhaps be make more sense to, instead of have a GTK state node, a G state node in a lower layer?
It could, I suppose. But the problem is GTK application needs to run all of this because there's involvement with Wayland, there's involvement with talking to a portal, which like GTK will do, but like glib isn't doing. Well, it does talk to portals sometimes, but it's not like GTK application will register with the portals. It'll give the portals an app ID, which with that kind of thing we do need for this to work for unsandboxed apps, for instance. So, and it also needs to be aware of GTK windows, because otherwise we get all these edge cases that you would have to handle yourself in the app, which is, I don't think that's a feasible solution there. So because all the logic to drive this is in GTK, then does it make sense to put parts of it in glib? I suppose it might. Maybe you do want to serialize something, just anything that could use glib. That might make sense. But also glib doesn't really want to accept new APIs unless they've been tested somewhere else first. So maybe we keep it as is in GTK for GTK4. And then in GTK5, maybe we decide that this API is good and works, and then we can upstream it into glib and then to do something like that. I don't know.
So one last comment, because we are running actually over time. A person in the chat, thank you so much to people who are actually interacting remotely. He's saying about the question that the gentleman did before. Their question is actually, they have written a shell extension that already implements session save restore in some way. What does this new development mean for their extension? I'm going to ask you to be very brief if you have an answer for this. Not about saving state of extensions.
Okay. I see. I imagine that if there's an extension that implements this feature and then apps just natively support this now, then that extension probably isn't necessary. But there will be a transition period where apps do need to opt into the system. So for apps that don't opt in, the extension might need to keep working for those apps, maybe, like if you want to do it that way.
Thank you very much. Thank you. Once it's ready, I can go right away. It's in one. No, just him. Felipe, it's only you, right? Okay, cool.
So should I hear?
Kind reminder, while Felipe is setting up, if you have questions for the AGM, Maria has sent a message in the GUADEC attendees matrix chat with a link where you can add your questions. Please do so in advance. Send the questions as soon as you can. The link is going to be available up to 2 hours before the AGM, okay? And yeah, now we have Felipe Borges. He is going to talk about the future of boxes.
Thank you.
So you might have heard of me last year talking about the future of boxes. So this is not a rehearsal of that. It's actually like a follow-up of that, or maybe the future is now. Jakob was actually very kind to remind me that 13 years ago or so, when we did a GUADEC here in La Coruña, which was actually my first GUADEC, there was a tech preview of the first version of boxes. So kind of coincidentally, we are doing a tech preview of another version of boxes right now. And this is the work I've been doing for the past 2 years or so. And I'm going to talk very briefly about summarizing why I've done it and how I have done it. But then I want to get into demo time, because last time I think that one thing that I dropped the ball was actually not showing anything in action. I felt back then that maybe there was some foundational things I want to get together first before I got all the more eyes into the thing. So I feel that right now I think I'm kind of ready to get some user testing, some feedback, and other things. So that's why I am doing this follow-up talk. And yeah, so Boxes started like in 2012, right? So it was early GTK 3 type of days, and we were still very behind on the way we were developing apps in comparison to how we do things now. And it was built by a lot of people at Red Hat around the Spice technology, right? And this is very important for what the reason why I have to do this rework now. Because the Spice is this remoting technology that allows you to like remotely connect to another desktop, but also works for local VMs. So that's basically why Spice was chosen for Boxes. So not only drawing the display widget, but also Spice does the host-guest integration. Like the host is your system, and the guest is what is being virtualized. And Spice has also like the input, forwarding, file sharing, clipboard, all these kind of nice features. But yeah, Spice had its own team at Red Hat, and Zishan was like one of the main people behind that version of Boxes. Then Zishan like left Red Hat and started working on other things, and I was interested in like learning new things. I was still working at the time in settings, printing things, and document viewer. So I wanted to try new things, and Boxes was something I was very interested in because I was a user of that app. So that's when I got involved. It's been 6, 7 years since that happened. Then we went through some dark ages because the Red Hat decided to move forward with RDP and not actually continue with Spice, business-related things, but the Spice team has been disbanded. Everybody's okay, working on other things. They were not fired, but the Spice project kind of got deprecated, and Spice was written in GTK 3, and there it does a lot of input and a lot of like deep, low-level things, so that was a really hard thing to port, especially not having active upstream. The folks that were very knowledgeable about this, they were busy working on other things, so the project sort of stagnated. We also had conflicting opinions about how to design an app architecture, so I think the Boxes kind of became a bit of a code rot because we had like very different features implemented in very different ways. Like there was a lot of abstraction in some perspective, other composition in other, procedural generation of widgets versus like declarative. So I am guilty of contributing to that code rot, and I saw that we were getting in a place where new contributors were not really interested in diving into that code base. It was just really hard to digest. So then, Marc Andrea, which was actually a person who was involved in Spice, developed the QEMU debuzz display, which allows us to basically access the display of the virtual machine over debuzz, like having APIs for that. And then Christian Hager developed libmks, which allowed MKS standing for mouse, keyboard, and screen. So that was a new hope because it allowed us to use a GTK4 widget for drawing the screen of the virtual machine. And that basically gave me an opportunity to start from the scratch. Since Boxes was very tied to Spice, I felt like replacing the engine of the car, it's really hard. Maybe you'd rather build a new car around the engine, a new engine. So also because libadwaita GTK4 was coming, and I wanted to be part of this new hype of app developers, engage new contributors, and for that I needed to have a code that it's approachable by everybody, sustainable. So that's why I decided to do this rewrite. And since Spice was removed from RHEL, I became maintainer of GNOME settings, and Boxes became kind of my side project, something I was doing more on my free time. And Red Hat has been very kind to allow me to do this on my working hours, but it's like not as priority as the other settings work. So things start to move there pretty slowly. And I actually found some new passion for developing apps because nowadays it's much better tooling than when I started. The toolkits are much nicer. So that's how I decided to keep trying on this front rather than give up on boxes. So last GUADEC, I had a talk about this whole journey about developing the thing. In Linux App Summit in Albania, I kind of described a bit of my architecture decisions about how to do things. Long story short, I have like a libvm that is like a static library that is inside Box that does all the virtualization libvirt things, and then I have like UI in a very separate namespace, so it's just very well divided, and we can test the backend code separately, and then the UI it's just like living separately, which was a big mistake of the previous Boxes implementation, that they were very entangled. But anyway, like you can check those talks. I'm going to be linking to them later, but I wanted to actually make this a demo presentation, and that's when things usually go wrong, right? So bear with me. So this is how the new Boxes thing is looking like. You can see prominently that we have some custom icons. Jakob has been working on them. This is very recent work, so he's doing his pixel art work on those icons. And yeah, it kind of resembles the old Boxes. But I wanted to show you that things are working, and nothing better than just like showing them working. So let's start with our favorite OS, GNOME OS. So as always, like by design, our creating a box dialog needs to be stupid simple. It needs to be for people who do not know anything about operating system internals, virtual machine internals. This is like, I just want to get another operating system running, and these are the very basic things. Firmware choices there is something that I'm very close to getting rid of that UI element, because we are flagging in the libOS info all the operating systems that we know to support certain firmware, the ones who require and the ones who support. So we can, for instance, for GNOME OS, hide that entirely, because we know the GNOME OS is UEFI only, and we probably want all of the OSs to be UEFI only. That's why we are calling the BIOS as a legacy BIOS. But anyway, let's go ahead and create. So here you see the libmks display. And let's boot. So Boxes is booting on the ISO. GNOME OS is extremely fast to install, so I think we're going to be able to be doing even a quick installation in here. So let's go GNOME OS. So old GNOME OS ISO that I had around, but still works the same. So what I am actually going to show with this step is that differently than other virtual machine managers, Boxes kind of tries to abstract away the whole idea of a virtual machine manager having to expose how operating systems work. So here what we did is that we installed the operating system and create a virtual disk. So Boxes knows that this virtual disk has files on it now. So it detects by checking the file size and comparing, and then already goes and switches the boot order from booting from the installer into the install disk. So that basically means that now if I click here on GNOME OS GUADEC and everything worked correctly, I should already be booting on the right disk, right? So this basically allows me to perform my installation in the way you kind of be performing in real hardware. This is the moment you would unplug the USB flash disk, or that you would be removing the CD-ROM. We are still using Spice for certain things, especially the things that don't involve drawing and anything. So for instance, specifically because I want to leverage the idea that most distros are already shipping the Spice agent. So the Spice agent is a process that runs inside the operating system that provides that connection with the host. So for instance, here I can copy some text and paste it on my host, and that would work the other way around as well. So I can already copy and paste it on the virtual machine. So that it's still working, even though we changed the display widget, it's still working through Spice. So another place where a lot of work has been happening is the properties dialog. The properties dialog is specifically the place where I feel that most users shouldn't have to go, because you're just playing with your virtual machine, you're sending files and stuff, but there are advanced requirements for users, and I want to cover those specifically because I am supporting image-based operating systems, and Boxes is the only virtual machine manager that actually runs entirely in a Flatpak container. Like it runs with its own libvirt and QEMU inside there, so you don't need anything on the host. Other virtual machine manager applications usually are going to connect to a host libvirt session, so that's not necessarily like self-contained. So when you want to support more advanced things, you might have to end up on the properties dialog. So for instance, here we have the resources. Jakub and I have made this very nice sliding resizing widget that allows you to change the size of your virtual machine disk. I have here like an early draft of network settings. I'm doing port forwarding. I use this Google alert, which basically notifies me about what people are writing about Boxes on the internet. And one of the main the top research that people have about Boxes is supporting Windows 11. And the other one is how I can connect to my box over the internet, right? My boxes were often isolated on the network. So now we support port forwarding in the Flatpak, so that's working. And yeah, the other things we already supported, which is a removable device. Snapshots are also already implemented. I did a new log view, and then the old school libvirt fancy configurations and stuff. So for instance, let's boot this Fedora OS and try to see the networking things, if they work. Because I think that this is like something people have been wanting for a long time. So yeah, sometimes I feel that Fedora has SELinux, and SELinux often blocks SSH connections. But we have, for every virtual machine that we are creating, a vSoc virtual device being created for this. So for instance, I can just enter my credentials here for SSH. And I got this terminal window behind. Seems like I'm getting my password wrong. Maybe caps lock. Oh yeah, caps lock, it's on. Right, so now I got in. So I can, for instance, do a notify send. And so I can already SSH into my machine. Other cool feature that's one still provided by Spice is the file sharing. It's still there, so like I can, for instance, pick a small file here and just send, and it's already there in the downloads folder, so I just send a file into my virtual machine. But anyways, back to the most researched topic in Google Alerts, which is installing Windows. As you know, Microsoft has fucked it up with Windows 11, that they are requiring that you throw your laptop away and get a laptop with a TPM device. So a lot of users of Boxes were frustrated that they could no longer virtualize Windows. And I saw this as an opportunity because if people are to migrate to Linux, they might still depend on some Windows workloads. So having a Windows 11 VM is something worth doing. So here I downloaded an image from Windows 11 from the Microsoft website. They make it publicly available, and I'm going to go through the installer. What you saw in the past when you're trying to install Windows 11 in Boxes is that you just fail because you don't have the TPM device, you don't have security keys, secure boot, and all those things set up. So that's something I spent a lot of time trying to crack, and now I managed to do so. So if everything goes correct, you're going to see that the Windows installer goes through the part where it checks for hardware capabilities. So now we are finally able to do a Windows 11 installation. The installer is still not running with the Virtual driver, so that's why you might not see such a nice drawing on the widget. Yeah, I don't have a product key, but you can still continue forward with the installation if you don't have one. Let's install this one. So you see the checking PC thing flashed pretty fast, and it already went through. So if you got to this stage of the license, it means that your hardware is capable of booting Windows 11. So basically now Windows 11, you could continue here and install Windows 11. But this is going to be very slow, so I already have one that is installed. We have a Virtual Win driver for Windows, so you're going to have like some, if everything works, you're going to have like a nice resolution for Windows, and also Spice Agent for Windows. This Boxes version can mount the Spice Agent file as a removable device for Windows. So once you are booting for the first time, you're going to be able to install the Spice Agent on Windows. You're going to have a notification on the top telling you that the guest agent is not connected, that you should install it if you want more advanced features. Oops. So Windows. So that's how Windows 11 looks like. And same thing. And same thing as before, I can send a file and it's going to show up here on my Windows desktop. I also can share clipboard between my host and the Windows guest. So here I could paste what is already on my clipboard, the hello string. So that also kind of working entirely out of the box. Yeah, I think that's basically what I got so far. I also put together a mini website at nightly.gnomeboxes.org. Gnomeboxes.org is still pointing to stable, but nightly.gnomeboxes has instructions about how you can test this. This is on the GNOME Nightly Apps Flatpak repository. So I would like to actually get people testing and filing issues. In this website, there is instructions about how to file issues. There is also a list of the features that are already supported. And yeah, I would like to stabilize this because I see that we are releasing GNOME 51 in September, I think. So I think we have time for me to get this to replace the old boxes. I also have migration script for old Boxes virtual machines. This new version of Boxes can create VMs from VM disks. So basically, you can just open a file, and that file can be your old Boxes virtual machine. So you can have new virtual machines living on that one file. So this is also a way that you can share your virtual machines. You can, for instance, get the disk of a virtual machine and export. That's actually something I didn't show. But I could, for instance, get this GNOME OS VM exported to a different location, and that basically would create a GNOME OS kickoff file that you can share with your friend, and they are going to be able to boot that same virtual machine that you shared. So it's basically a way to send your virtual machines around or make backups of your virtual machine, and also a way to migrate from the old virtual machines, the old boxes to the new boxes. So yeah, please visit this website and help me with the testing, file issues, and I hope I'm going to be able to cover all the features that we used to support. I am starting working on the USB redirection now. The new USB devices portal is helping a lot. I have some patches in QEMU that is going to be able to hand over a file descriptor of the device to QEMU, so then we're going to be able to actually offer it as like a real physical device to the operating system, rather than plumbing through SPICE, because the SPICE still would require the agent and libUSB and a bunch of privileged things to happen. What I don't have is the bridge network. I think for that maybe we want to build a network portal type of thing, so you still, oops. You still don't have a way to have a public IP address to access your VM, so this is just port forwarding. But yeah, I think it's enough for you to SSH with vSock and also SSH for port forwarding or access HTTP and things like this. So I think it's already pretty functional. You just don't get one VM to access another VM because of the lack of the bridge, but that's a problem that we are probably going to be solving next. So yeah, these are basically the things. We used to have this OS store in Boxes where you could download a bunch of operating systems. This is something I want to consolidate on the designs with the design team, but I already have an implementation that looks more like Bazaar, GNOME software type of thing. So you basically could browse Ubuntu and then choose a version of Ubuntu and types of architectures, and then you download, and then you would create a VM from Boxes. Yeah, and automated tests, I want to do some more testing since I basically built this architecture where the backend is separated, so it's much easier to test. I already have a test for the creating VM, resizing the VM, but there's other contexts that I want to. I'm running out of time, so I want to show acknowledgements of everybody who has been involved, people who have worked on the previous version of Boxes that was a great inspiration for this new build, and also people who have been working on this new version. Jakub Steiner has done the icons, a lot of the mock-ups, so I'm very thankful for them. And Christian Hager worked on libmks, Jordan helped me with the CI, so it's a lot of people, and it takes a village to build something like this, so I'm very thankful that this is available, and please go out and test. You can contact me on this address. This second one is my Mastodon account. And yeah, that's all I have. I think we are good on time. Sorry, I had to really speed up.
Yeah, the more time passed, the quicker you started talking. Sorry for the pressure. Unfortunately, we don't have time for the questions, but we have a round of other presentations, the lightning talks, which I'm told you can have.
Yeah, I am hosting those, yeah.
Perfect.
So we have 2 interns that are here. I guess you could come to the first row if you are going to be presenting. But for starters, we have 4 interns that have not been able to come here, and they send us a video, so I hope to present their videos instead. So let's start with them. We're going to have these 4 interns, and then we're going to have the other 2 interns finishing. Oops.
Front, left, front, right.
Yeah, I'll be playing some audio, so in case the audio is low or something, you might want to tweak your knobs over there. All right, so as you know, we work with Google Summer of Code and Outreachy to offer internships to bring new people to GNOME. And our interns have been working with community members as mentors. And unfortunately, some of them couldn't be here. They send us presentations. So this is where you get the chance to get to know more about the projects that they are working on, who they are. I incentivize you to actually reach out to them and try to make them welcome in the GNOME community, because our main goal with internships is to attract contributors long term. So once you get to know what they are doing, and if you are interested on that, please follow up with them. So we're going to start with the first contributor that is working on Mutter. I'm going to play his videos.
Hey again, everyone. I am Toluwaleke. By now, you've probably seen my lightning talk video about my GSOC project working on Mutter, but this is me introducing myself. I am Toluwaleke. I'm from the southwestern region of Nigeria in Africa. I'm not a student, actually. I am a graduate of computer engineering, a recent graduate of computer engineering. I got into open source in 2020 by developing personal projects, not contributing to more established projects. But through developing my own projects, I got involved in other similar or related projects that were more established. And through one of those projects, I got to know a man named Hans-Peter Janssen, goes by HPJ, and towards the end of my bachelor's degree in 2024, I reached out to him for some career advice. I was interested in the systems programming field, but I did not know much about it, and I wanted to ask someone I thought was involved in the field, and he happened to be the only person I knew, and I reached out to him. We had a call, talked for some hours. He gave me some advice and introduced me to GNOME. I've always known about the GNOME desktop. I've been using Linux since 2017, so I've used GNOME ever since. And but introduced me to the community and the project itself. And God told me to give me some history. And after the call, introduced me to Federico, and Federico welcomed me and told me some things I could do to contribute to LibreSVG, and I made some contributions in late 2024 to LibreSVG. Early 2025, I made some more contributions, and then I applied for GSOC. I got selected, worked on, I added printing support to crosswords, and that was a wonderful experience. I worked with Federico and GRB on that, and I continued to work with GRB till 2026. During that time, I applied for a number of jobs, but none of them worked out. But anyway, GSOC came again this year. I saw the GPU reset recovery project, and I was like, this is a wonderful project in the field that I want to go into, which is graphics programming. And I applied and I got selected. And thank you very much for the opportunity. Thank you. And so I'm currently working on that. And I intend to, after my internship, I intend to stay and continue to contribute to GNOME. And I hope to get a job that helps me or allows me to contribute actively to GNOME. So, yeah. So thank you very much, GNOME, for the opportunities. Thank you, HPJ. Thank you, Federico. Thank you, JRB. Thanks to Jonas, Carlos, Robert, everyone involved in my journey. Thank you for all the opportunities. I really appreciate it. And bye.
So they.
Hi everyone, I'm Toluwale.
He also sent a video of his project itself.
Okay, for GSOC this year with mentors Jonas, Robert, and Carlos, I've been working on Mortar, GNOME's compositor, on a problem that has been affecting Linux users for a while. What happens when GPU resets? Here's the issue. Sometimes a hardware or driver fault causes the GPU to reset. When that happens, the graphics context and everything in GPU memory, textures, frame buffers, all of it just disappears. Right now, Mortar has no way to undo that. Depending on your driver, one of two things happens. Either your screen just freezes on the last frame is managed to render, or the driver kills your session entirely. Either way, you lose everything. Every open window, every unsaved document, gone. So here's what I've built. At a high level, it consists of 3 steps. Detect the reset, recreate the graphics context, restore everything through the compositor. Let me show you what that actually looks like. This is the core of it, a 5-state recovery cycle split into 2 phases. In the reset phase, we detect that a reset has occurred and we poll, waiting for the hardware to actually finish resetting because it's not instant. Only once that's done do we move to the restoration phase. We create the graphics context, propagate the change through the compositor, and if all that goes well, we are back to normal operation. If, however, the restoration fails after enough tries, we exit gracefully instead of hanging forever. The full write-up is linked in the last slide if you want the details. Here's what it currently looks like. A reset happens, the display goes dark, and then it comes back. Windows are rendering again, input works, the session survives. It's not finished yet. Right now, getting the display back needs a small manual nudge, and the desktop background is still broken after recovery. I'm currently working on that, but the core idea works. A GPU reset no longer means losing your whole session. If you've run into this issue on your machine, I'd love to hear about it. Come find me on Matrix or GitLab. Thanks to my mentors for all their guidance thus far, and thank you all.
Hello, my name is Angelo, and I'll be presenting about my GSOC project titled Adding Debug Adapter Protocol Support to GJS. Currently, if you have a GNOME JavaScript application and it has bugs, you will need to debug it. Currently, you need to use GJS's little-known text mode debugger, which works similar to GDB. To use it, you type break, continue, list, and other commands manually, while most other languages already support a visual debugger. Let me show you how debugging a GNOME JavaScript application might look like today. So I have a script called test.js, and it just loops 60 times and waits 1 second each iteration before printing the iteration number. To debug it, I will invoke GJS like this. I'll set a breakpoint on line number 7, which is where we log, and continue execution. When the breakpoint is reached, I can see where I'm at by doing list, or typing frame so I can see the current stack frame. After that's done, I can also continue execution. This can be made better by using the DAP or the debug adapter protocol. It is a standard layer between an editor and debugger and allows them to communicate. Here is an example of how it works. We have different editors and different debuggers communicating all via the debug adapter protocol. Let me show you how Node.js currently works by leveraging the debug adapter protocol. I have the same script as before, just pulled in my favorite editor. And to set a breakpoint, I just need to click in the margin. After that's done, I will run my debugger using F4. And when it breaks, I can see the current iteration number here. I can also see the other variables. I can even resume execution simply by pressing the play button. My GSOC project is all about bringing the current debug adapter protocol support to GJS, and I've already made some progress. So far, I'm done with the initialization bands. I'm currently working on breakpoints, stack frames, and more. In the future, I'll be implementing stepping through the code, exception handling, and the VS Code extension, and there's a few extras if time permits, such as GNOME Builder and source map support, and maybe support attaching to already running programs, and maybe, as stretch goal, support debugging the GNOME shell. Thank you, this has been my project.
Hi everyone, I am Shivam. This summer I have been working on putting GitG to GTK4 as part of GSOC 2026 with my mentor Alberto Fenzu. So before diving into the project details, just a little bit about myself. I am a sophomore electronics engineering student from India. GNOME was actually my first big open source project, so pretty much everything I have learned about contributing to large projects has been through this lovely community. And I use Emacs with evil binding, so hopefully nobody judges me for that. And yeah, I love GNOME. So for someone who haven't used GitG before, GitG is basically a Git GUI, so you can pretty much do every Git operation like cloning repo, viewing commits, pushing new commits, checking out the other branches and all inside of a really pretty environment. The GitG project itself was announced in 2008, so that makes it quite old. And this is how GitG as of now looks on the GTK3 toolkit. Moving on. So what does this project actually brings? Firstly, it gives the application a much needed modernization. It also makes the interface feel much more at home with the rest of the GNOME environment. So if any new user is using the application, the experience will be much more consistent as of now. And since we are moving to GTK4, the app should also be much more performant thanks to GTK4's modern rendering pipeline. And finally, the migration will also serve as a good foundation to add new features. Now, what is the current status? Well, I would say most of the heavy lifting is actually been done. The biggest milestone so far is that libgitg has been ported to GTK4. Well, that's the core library behind GitG. It handles the Git models and have a lot of reusable widgets that the application depends upon. We have also migrated most of the UI files and a good chunk of GitG source code have been ported as well. Now, the bad news is that the application still isn't buildable yet. There are still a few missing pieces that needs to come together before everything works. But hey, we are getting really close. Hopefully we'll have a buildable GTK4 version very soon. So the future plan for the project is to get a buildable GTK4 branch as soon as possible. Once that's done, we will spend most of the time refining the user interface and making sure everything feels polished. And the future plan for me, I see myself continuing improving the GitG and the GNOME as a whole. So that's pretty much it. Thank you all for taking the time to listen to my talk. I would also like to give a special thank to my mentor Alberto for all his guidance and support throughout this project. I have learned a tremendous amount from working with him. Thank you all.
Hey everyone, I'm Jagat, also known as Sham. I'm a computer science undergraduate from India. This summer, I worked on my Google Summer of Code project, that is, adding native uninstall option to GNOME shell, with the guidance of my mentor Adrian, who has been incredibly supportive throughout the program. A little about myself. I have been using Linux for the past 4.5 years, and GNOME has been my primary desktop environment. For a long time, I wondered why there wasn't an uninstall option when I right-clicked an application in the app grid. At the time, I really don't know how I could contribute to GNOME or have enough skill set to contribute. But now, when GSOC 2026 projects were announced, I saw this project and thought, yeah, this is a perfect opportunity to contribute. Before this project, if someone wanted to uninstall an application, they had to open GNOME software or use a terminal. Many users naturally expect an uninstall option to be available directly from the application's context menu. This summer, I worked on making that possible. To implement this feature, we introduced a debug interface called App Store Integration. Initially, I thought GNOME software should own the interface. However, after discussing the design with my mentor, we decided that GNOME shell should own the interface instead. This allows any app store such as GNOME Software, Ubuntu App Center, or Snap Store to implement this interface instead of tightly coupling GNOME shell to a single app store. When the system starts, the application store provides GNOME shell with a list of applications that can safely be uninstalled. It also indicates which application supports data removal, such as Flatpak applications. As a result, when the user right-clicks an application, GNOME shell already knows whether to display the uninstall option and whether it should ask about deleting the application's data. So, what exactly happens after the user clicks uninstall option in GNOME shell? This is where GNOME software side of the implementation comes into play. The debug interface provides two methods. Those are get uninstallable apps and uninstall app. Let's look about get uninstallable apps method. This returns a list of applications that can be safely removed. It also indicates whether an application supports data removal or not. And another method will be uninstall app, which performs the actual uninstall operation using GNOME software's existing uninstall backend through a GS plugin job. And also, in future, we can add drag and drop support to uninstall an application in GNOME shell. So that concludes my presentation. I'd like to thank my mentor Adrian and the entire GNOME community and everyone who made this project possible. Thank you.
So now our interns that actually attended the conference are coming.
All right, let's see if that'll come up. Not receiving anything, so ya está. Okay. All right, so I'm Michael. I'm doing the Pativi ruler rewrite in Rust. My mentors are Yatin and Aleb. So far we are pretty much done with drawing. I was instructed to do a standalone Rust widget first. Oh, it's not letting me move to the next slide. Oh, there we go. So a couple of things with this. I reached out to some video editing communities. It seemed like they really cared about the minor ticks landing on actual frames. So as you zoom in and out of the ruler, the minor ticks are asymmetrical. They change as you zoom, but they stay lined up with the actual ticks. And then, yeah, I'm rendering one interval between major nodes and then painting that across the ruler. And the Pango text markers, caching them and keeping that optimized was a pretty major part of the drawing itself. Another thing we did is, let's see if I can move on to the next one. Okay, there we go. So we decided to implement a full-out JTK layout manager and a layout child so that the playhead is no longer in the ruler. We're going for a dumb widget, smart app kind of approach. And so the playhead is just a child along with any number of children that we might want to create to lay on top of the ruler, such as markers or brackets or anything else. And when I was first when I was first writing my proposal for the project, I found the RDW repo and thought that the GObject bindings wouldn't be so bad. I thought I could kind of copy the structure I've seen. I'm realizing as we actually try to implement them that they are much more complicated than I had expected, and so that's kind of the major next step is not only making the custom bindings work, but making sure that they're safe and done correctly, which is going to be a pretty major part of this project. And then we actually have to implement it into the PTV app. So those are the next steps coming. All right, thank you.
Hello. My name is Laureen Kaliman, and I am the Google Summer of Code intern this summer for adding vocab-style crosswords to GNOME crosswords. A little bit about me. I'm a computer engineering student at Rose-Hulman Institute of Technology in the United States. My mentors for this project are Jonathan Blanford and Federico Mena-Quintera. I apologize if I mispronounced anyone's name. Both of them have welcomed me very warmly and have led me greatly. So traditional crosswords are sort of like your New York style crossword. They're a set grid. You know, sort of predetermined where the solution is ostensibly supposed to go, and you just fill in where, based on the clues that you're given, where you think the words will go, and sort of backtrack from there yourself. It's very manual. Versus what I'm doing this summer is vocabulary style crosswords. What these are these take words from a list provided by a user, and using an algorithm, we place a word at like the root origin, like 4 across would be the example here, and we sort of branch off from there. There's a lot of constraints, like for instance, if you can see my, yeah, you can see my cursor. We don't want to have islanding words that, for instance, wouldn't fit on this coordination. We want them all to be connected to each other. We don't want 2 words to sort of start and end hugging each other on the same cell, nor similarly, we don't want words sort of directly hugging an entire row of cells. Okay, so this is how the editor looked, an older version of the editor. I will be contributing to the libipuzz library, which is the puzzle library, the crosswords editor, which is essentially where the user changes and inputs their word list and manipulates it. This is also like where you choose the type of crossword. And then this is the actual game format itself. You would have, this is the New York style, right? So you would essentially have your list of words across, down, and clues. For us, the clues would be around here somewhere off to the side. Big picture. Like I said, with the constraints, for instance, we don't want to potentially overwrite a word while we are filling in. If we have 3 words where 2 or all 3 of them can intersect with each other, we don't want to overwrite any of those letters. All words have to connect. There's no islanding words. They have to stay at the moment within a designated border. Right now we're looking at a 30 by 30 grid on a coordinate system, and of course, time. We want the grid to actually be generated reasonably with time. So all of these include what I've done, which is adding support to libipuzz, the puzzle library. We'll have the user create a list of words and their clues related to it, because we kind of can't do that for them. And we'll place sort of a root word on the origin and build from there like a tree, and backtrack as well, which is kind of the heart of this whole project, because we want to fit as many words as possible on this coordinate system. So we want to backtrack, retry words at a different sort of location, try to refit words, so on and so forth. So right now we've done a lot of the back end of this, and I actually don't need to show you this. I could just sort of show you a demonstration and the code briefly itself, since no one will actually have time to read any of these. Oops, that's my header file. Okay, I may have crashed that ghosty. So I'm just going to show you the demonstration. So let's say I have 3 words, beach, cat, and taco. These were provided to me earlier by Federico upon a conversation. So we want to start sorting with the longest word first. So here would be beach. And let's say I go on to the next longest word, which would be taco here. However, that leaves me unable to fit cat without sort of violating that bordering next to each other. So what we would do is we would just backtrack and eliminate the T, C, O, and then using our beach that's staying on the screen in its state, we rewrite it instead with cat. And then we retry taco, and it fits, and we've got a good grid. So goals by the end of the summer is, right now my program is synchronous. We want to make this asynchronous, especially for time, like generating the grid. I want to add the option of the vocab crossword to the editor. Right now, it's just sitting in crosswords itself, and manage the front end, because right now we've only written the back end. And yeah, thank you, GNOME Foundation, for inviting my participation. This is my first big open source project, and also Google Summer of Code for accepting me in and sort of offering this guidance. Yeah.
Thank you. So unfortunately, we didn't have other interns coming, but we have these 2 interns here and a couple of minutes for questions. So does anybody actually want to ask them any questions? We had the project about crosswords and the one about the PTV ruler port to Rust. Worth mentioning that we have the internship channel on Matrix. If you're interested in getting involved, being mentor, or talking to the interns, that's where you can find them.
If I'm not mistaken, does this mean that PTV will now be some Python, some C, and some Rust? Nice.
Yeah. Anybody else? Words, comments? One, two, three. I guess we could wrap up. So yeah, thanks everybody for the internship lightning talks. And yeah, as I said, we are really looking for mentors, people interested in helping, also being org admins, which are the people who support the interns. So if you have any doubts or questions about how to get involved, you can also reach out to me. Thank you very much.
So yeah, I think this is a wrap up for the second day of GUADEC. Kind reminder, if you have questions for the AGM, please send them in the link at least 2 hours before the meeting, otherwise they won't be able to add them. And also, if you want lunch, if you have paid lunch, come and get your ticket. If you haven't paid lunch, come and buy a ticket. And yeah, I think that's it. See you tomorrow.